Just wait for another 2-4 minutes. I hope second recording was proper. Now I think we are good to start. So just wanted to check, is there any question related to the previous discussion?
Chinmay, I have one question related to ANOVA.
Yeah.
Whenever I am using, there are two syntax, either ANOVA or AOV. Is there any difference between both of the syntax?
I would say in terms of result, you won't be getting difference.
Okay.
So these are coming from different packages, but you can use either.
Right. And one more question related to chi-square. Chi-square is only for contingency table or it is for a independence test also?
No, it is technically, I will tell you. So there is a technique called CHAID, CHAID, chi-square automated
Yes.
interaction and detection. There we use chi-square. So when we go to the tree-based algorithm, we'll do some detailing that what are the other contexts to use chi-square.
Right. All right. Thank you.
No problem. Is there any other question regarding EDA? Whatever the discussion we had, that was very informative. So what I'm expecting that you people must have gone through the recorded videos and the slides.
Yes, sir.
Okay. Now I'm going to open the slides and we'll take from there. So do you remember till which slide we discussed?
I'm done, sir. So established.
So this was done, correct? This was done. Wait, I think these all were done. I was, no, I think it was. Critical region.
Before slide.
The tests were not done.
Okay. This one not done.
The common test. No, this was not done.
Yes.
And
Yeah.
the tests, yes.
This was done.
This was done. The last slide you have.
Okay, perfect. So now, let me attach my pen tablet because I need to write some information. So I will set certain rules here that will give some ideas. So in statistics, there are two families. So if I talk about a test, there are two types of tests which happen. One is called parametric, and second is called non-parametric. Now, in a real life scenario, if I talk about the applied data science, almost your 95% cases comes here, and at max I would say 4 to 6%. So I'm giving 5%. So these are the cases comes. So majority of the techniques that we are going to learn, those falls under the parametric. Non-parametric is something I will explain what is non-parametric, but what all learning we are going to do, those majorly falls under the parametric. Now let's understand in detail what is parametric. So parametric has certain definitions. So first is saying normal distribution. Second is saying that it has some predefined distribution. And third is saying that there is what I say pre-known behavior. Wait, this is so many things comes. Wherein people primarily in majority of the books you will find that the normal and predefined distributions are mentioned. So when you have some data and you are going to compare that data with something which is predefined. So be careful. The moment I am saying predefined distribution, that means any kind of distribution wherein a table exists. Fine. So you have like Z, T, F. These all are the distribution which are a kind of predefined distributions, and in that case we use parametric. Non-parametrics are, so what I'm saying that I'm talking at the very high level. So non-parametric are those scenarios wherein your distribution does not follow uh, a kind of symmetricity like normality, or it is not on the base of some numbers. So let's say that you are getting some distribution with not the nominal variable, with not the continuous variable, you are doing something on nominal or ordinal variable. So that falls under non-parametric. We'll do some detailing going forward that what all comes under non-parametric. But here we are going to talk more about the parametric. So for your understanding, parametric is something which may follow normal distribution or wherein we have some predefined distributions. That's what we call it parametric. Now, then coming here. So here it is saying that check the data. Check for normality. If it is normal, it goes in this side. If not normal, then it goes in this side. So look here, it's saying that if data is not normal, it is going under the non-parametric test. That's what one of the assumption I wrote, that this data is following normality or it's not following normality. Now, then let's say that your data is following normal distribution. And the moment it is following normal distribution, you can either work on mean or you can work on the variance. So the moment you are working on mean, so in that case we discuss about Z-test, T-test, ANOVA. These are all the calculation which moves around mean. But if you are going to consider variance, so in that case you need to use F-test. So F-test primarily talks about the variance. So here it is important for you to know or remember that there are two ways to compare. In first scenario we talk by mean, and in second scenario we talk by help of the variance, that how the variance of the data is. So in case of variance we use F-test, that is also known as HOV, H-O-V. This is indicator of homogeneity of variance. Homogeneity of variance. So that's what we'll talk more about, this homogeneity of variance in linear regression. So this everything is going to come. So these are the multiple branches. So in parametric, this is what all comes: Z-test, T-test, ANOVA, your F-test. But in non-parametric, there are many others. I hope this difference is clear between parametric and non-parametric.
Yes.
Fine. So now, because this will differentiate, as I mentioned that in applied data science, our majority of the problems are solved by this parametric test. There are certain instances where the non-parametric comes. We'll talk, this non-parametric will come in deep learning kind of scenarios. We'll talk more about that. Now, when we talk about the parametric test, which is essentially normal distribution. So normality test, saying that normality test establishes if the data approximately follow normal distribution. That's what we try to check or we try to test. Now, tests for hypothesis are different for normal and non-normal data. Hence, the need to first check the distribution type. So as I mentioned that for normal and non-normal, that is, which is not having the symmetricity, you have different hypotheses. Now here it is given that what are the common tests to check for the normality. I would say 4 tests are mentioned. One is called the normal probability plot. Second is Shapiro-Wills, Anderson, KS test, that is Kolmogorov-Smirnov test. There are 4 tests. Out of that, we are going to talk about normal probability plot. That's what we use primarily in data science. Shapiro-Wills, Anderson, and KS. These has the very limited applications. Like KS test we use in logistic regression. Anderson Darling, that will never come in your entire learning process. Shapiro-Wills will come somewhere, we'll talk about that, but that's a very limited context. For us, this normal probability plot is what we are going to primarily focus to check that your data is normally distributed or the data is not normally distributed. As far as the other tests are concerned, I will explain it in the later stage. so it so happened that the moment you are given multiple tests, we must know that why multiple tests are given. That means there must be some limitation of one test. Let's say that, as I mentioned, that normal plot we use in majority cases, there are certain limitation of this normal probability plot. And the place those limitation comes, then these other tests come to fill that gap. So first of all, we need to know that what are the behavior, what are the properties of normal probability plot. Then only we'll be able to understand the Shapiro, Wills, Anderson, and Kilmaro. That's what I will do. So going forward, we'll talk about primarily about normal probability plot, and then we'll set the context or we'll set the ground rule to understand about the remaining test. Now, we are talking about the first one, like your normal probability plot. So here it is saying that what are the ways, how are the methods to talk about what are the graphical method to talk about the probability plot. In normal probability plot, your first plot is QQ plot. So QQ plot is your quantile plot. And I will demonstrate you that what the quantile plot is. So you will know the real meaning that why it is happening or how it is happening. So as I mentioned that for a normal plot, we have something called theoretical distribution. TSEO, theoretical distribution. This theoretical distribution may be your t-test, maybe t-test, maybe z-test, maybe f-test. That can be anything. Now, and let's say that a data is given to you. Let's say that you are given some data, and this data is having, let's say, some value, like your 35, 55, 46, 57, 78. Like I'm taking some data points. These data points are there. This is given. And let's say that to this data, you are going to calculate a z value for this. So we can easily calculate the z value or z value for all the given points. So this is saying calculated z or calculated z. Then we can find from the table what is the table z value. Getting it? Now, so we are going to compare our table z value with calculated z value. And what our expectation is that these two values, if these two values are looking similar, that's great. If these two values are looking similar, that's great. If these two values are looking similar, that's great. So I'm saying that whatever my calculated values are and what all my theoretical values are, it should look similar for the same record. Getting it? That means for the record first, what is my calculated value? If the table value is also the same, that's the best scenario. Fine. Now, let me put that into, let's say in a different way. So I'm saying I'm writing here. We'll give you the context. Let's say that calculated value is 2 and table value is also 2. Calculated value is 1.4 and table value is also 1.4. Then you're coming like 1.25. This is also coming 1.25. This is coming 1. This is coming 1. Sorry, 1. This is 0.75. I'm writing in a certain sequence so that your graph comes proper. 0.5, 0.6. Let's do 0.6. No worries. Then saying 0.2. This is also coming 0.2, and this is 0, and this is also coming as 0. Let's say that these are the scenarios. I'm going to plot it, saying insert, and I'm doing the line plot. Wait. Something wrong is happening. Yeah, that will give you the perfect meaning for that. You must have realized one thing, that if your theoretical and calculated values are same, this graph is passing through origin and it is technically going at 45-degree angle. Did you realize that?
Yes.
No. This is indicator of normal distribution. So when you get some theoretical value and you have calculated value, when you plot theoretical with calculated and it is following a 45-degree angle, that is indicator of normal distribution. That's what this graph is saying. This is saying that the quantile plot, wherein you have the sample value, one axis, and other axis you have theoretical values. That is, one axis is actual, other is theoretical. You can reverse. You can do theoretical on y and sample on x. It is not going to make any difference in your graph. So this is how the plotting we do. We plot between theoretical and the actual value, and then see that how your data is looking like. If it follows like a diagonal line, the way it is visible here, this is indicator that your data is normally distributed. Is that clear?
Yes, clear.
Now,
Yes.
this people ask,
One question. But when we calculate we got only one value of Z test,
no, it's not so.
and from the table,
It's not so. So you remember we have way to find the respective value for each and every individual. So it's not a while Z we calculate one value, but in this case, let's say that someone has given you this distribution and saying that can you calculate a corresponding Z value for this? Yes, we can calculate by using this formula. I will tell you.
X minus mu upon, yes.
So by that you will be getting corresponding to each and every record. We'll see some more that how the theoretical and the actual value is that comes in place.
Okay.
Fine, but this is, I think you got the idea that how QQ plot is done.
Sure.
Now, so what all is given here? The QQ plot or quantile plot is a graphical tool to help us if the data set plausible come from some theoretical distribution. That's how it is saying. We need to compare with that. For example, if we run the statistical analysis that assume our variable is normally distributed, we can use normal QQ plot to check that assumption. The way I mentioned, that's how we check the assumption. Now, second is in that series, it mentioned like the first is normal probability plot, graphical method. That is what it is talking about, the QQ plot. The second is given for Shapiro-Wills test. Again, as I mentioned that it is something which will be coming at the advanced stage. So it's saying that commonly used test for checking the normality of the data. There are certain assumptions. The null hypothesis is that the data comes from a normally distributed population. Alternative hypothesis is that data does not come from a normal distribution population. Fine. For that, we have packages wherein what we do, we pass the data in the Shapiro-Wills test and we get a W value. That's the W is coming from Wills. It generates a W value and we check the probability. If the P value is less than 0.05, then it goes in favor of alternative hypothesis. It's saying that it is not coming from a normal distribution. If the P value is more than 0.05, then that is indicator that your data is coming from the normal distribution. So there is a predefined test for this. We'll do Shapiro-Wills test in some of the technique and we'll showcase. But here, what is important for us to know that there is something called Shapiro-Wills value, that is W value. By using that, we test the normality that your data is following normal distribution or your data is not following the normal distribution. That is fine.
Yes.
Now, next is, as I mentioned, that this is going more like theory, that how it all happening. We, to the greater extent, will talk about the QQ plot. So now the next is talking about your this Anderson-Darling test. So here in the way we had information previously, we saw that there is some predefined notion or predefined process that talks about that your data is null hypothesis is something, alternative hypothesis is something. That's what here also we try and we do it. So it is saying that the data follow normal distribution, and the alternative hypothesis is saying that no, data does not follow a normal distribution. And there we check for this test. So I will tell you one thing. So as far as your Shapiro-Wills test is concerned, let me show you that how does it work, because you will feel that something improper happening. So just a moment, let me run it. So I wanted to run it. I will show you the code, that there are certain codes that help us to perform this task. I'm writing help, and that is Shapiro dot test. It is here. Okay. I want to know the library that it is coming from. It is part of the stat library. So I need to write library, and then it's coming like stats. Perfect. Wait, it's done. Yes. And you remember we had empty cars data. So I'm saying empty cars is equal to empty cars. And I got this data. And in this empty car data, I have, let me see the numeric. Displacement is the numeric variable. So I'm saying Shapiro test and saying empty cars dollar displacement. Okay, and let me run it. Look here. This is what it is producing, a W value, and corresponding to that W value, we are getting this P value. So we need to look at this P value. Getting it? This P value is saying that this is less than 0.05. So we can reject the null hypothesis. And null hypothesis is that data following normal distribution. That means if I talk about this variable displacement, displacement is not following normal distribution. Are you getting that message?
W value stands for Wilks value, right?
This is the Wilks value, and corresponding to that, we look the P value. So we always look at this.
So we consider only the P value then.
Yes. Even if you run the test of this empty cars, are you getting this is not following, looking like normal distribution?
Yes.
Hello, sir.
Yeah.
If the P value is less than 0.5, then we can consider as a normal distribution, right?
No, if the P value is less than, look, read the hypothesis. What is the hypothesis for Shapiro-Wills? Read it here. What is null hypothesis? It is saying that reject the null hypothesis if p-value is less than the alpha level. Got it?
Okay, sir.
I think now this is
Chinmay, what is W here?
what is?
W.
It is a calculation. The way we there is a certain mathematics by help of that this value is coming. So it is a statistic. It's a parameter.
Chinmay, that P W is below a predetermined threshold. What does that indicate?
This one.
Yeah, that point. Yeah.
If the t statistics is below a predetermined threshold. So let's say that we are talking at 95% confidence. So in that case, my p-value is going to be 0.05.
Okay.
Clear?
So below, yeah, okay.
So there are certain mathematics. Again, there is equation for Shapiro-Wills. That's how it is calculated. We are not going to mathematics part. We need to understand that when we apply the function, and if function is producing certain result, how to interpret it.
Chinmay, if we find W and it is coming 0.06, how to interpret?
No, it is not normal. So anything which is more than, if you look at this p-value, if this value is more than 0.05, that is indicator your data is normally distributed. That
So
value
this
can
P value is equal to that value, a W value.
If p-value is, what is
Sorry,
p?
this W value written beside the P value, there is a W value. So that we can check from table.
So for W, this is the test statistics for Shapiro-Wills, and
We
corresponding to
can check
this,
from it table.
no, we are not going to check. That's what I mentioned, that in R or Python, we are not going to look into any table. That's what your system is already giving this information.
Okay, got it.
Fine, that's how we check it. So as I explained that your hypothesis is that if the probability for W is less than 0.05, that is indicator that your data is not following a normal distribution. Clear?
Right.
Now, the next is, I think this is clear, that how this Shapiro-Wills, how we run it or how to look into.
Yes.
Now, the next is going to be the Anderson-Darling test. So what will I do for that? I will first run the, now if you see the hypothesis for Anderson-Darling, it is again saying that the data follow normal distribution. That is what null hypothesis. Alternative hypothesis is that data do not follow normal distribution. I will run some code and will showcase that what is happening. I would say that the more and more we graduate, we try to read the output. We are not going to look into any table because those table informations are already given here in your output. So there is a package called library. This is package name is normality test. This is coming from this package. Okay. And I am doing the same task. So I'm saying that ad dot test and passing the same one. Empty card displacement here. And let me see the result. This is also producing some p-value here. Getting it? And as I mentioned that this is coming from Anderson-Darling test. So this value is written as A and corresponding to that, this p-value is given. So we need to look for the p-value. If this p-value is less than 0.05, then in that case we conclude that your data is not coming from normal distribution. Fine. Let's do one thing. Let's create a normal distribution data just for our learning. That's what is happening. So I'm saying set dot seed and passing some seed. Let's say 1, 2, 3, 4. I will tell you that why I'm doing so. And creating a randomly distributed value. I'm saying x is equal to. There is a function called rnorm which produce the normally distributed data. I'm saying that I want 100 normally distributed data with mean as 0 and standard deviation as 1. So this function will produce 100 data points which are having mean 0 and 1 standard deviation. Got. Now, then I'm going to run AD test on this data. So let me run the AD test here on this data X and see the value. Wait, something wrong is happening. That function has not produced proper one. It is saying that the data follow normal distribution. Okay. A digital hypothesis if p value is less than alpha. No, that is fine. I think that function was not able to produce the proper numbers. But this is fine. Just ignore it. I think I will use some other data points and I will explain it. Ignore this for time being.
But I got the value.
You get the value, but that is not a kind of misinterpretation of that value. Even I got, but that is not aligned. So it is not of.
Here p value is 0.3495, which is greater than 0.05.
I don't know for me, it is why it is coming. AD test. For me, it is coming improper. I think either something wrong is happening.
I also got the same.
The one which I got or something else?
The
I
one
got
which
the
you
different
got.
value. I got the different value.
Something wrong is happening. So ignore it. I think from the
Sir,
yeah.
sir, when you set the seed, then your output is not randomly generated.
It is not so. It is not so. It is randomly generated, but every time I will be getting the same value. That's what I wanted. It will remove that, but that should not impact it grading.
Yeah, but
Exactly. This is the same value.
Right. But if you see, if I run next time, it will not be the same. Getting it? So your values are that's fine. I think you can. I will tell you that later on. I will explain you the meaning of the seed, that why it is happening. Now there are two scenarios. Understand it very clearly. You are going to generate 100 numbers, and these 100 numbers are randomly generated. Maybe a series which is generated, which is not normally distributed. There is no guarantee that this normal distribution function always going to generate random numbers which are normally distributed. That is the reason that if I run it multiple times, look here, this time it is saying 0.21. If I rerun it here, it is giving me something else. But yes, in the majority of the cases, it is able to generate the random numbers which are normally distributed. Now, when I set the seed, set dot seed, and saying, let's say something others here, and then I run it, it is generating some number. Every time when I run it, it will only give me the same value. Look here. Oh, wait. Oh, I need to every time run this seed. So just a moment. Are you getting this is giving 1.107? If I again run it, it will again give me the same number. That's what the role of the seed is. So seed help us to bring the same set of the random numbers from your experiment. I think you can, for time being, just ignore it and run it.
Sir, I think CDs can stop your output, like your output could not be changed because of seed.
I would say it is all random. Maybe like in this case, I'm able to get normally distributed data, but the moment I am passing seed like 1, 2, 3, 4, getting it
So
here.
if you are not comment the seed, your output is stopped. Like your output is not could be changed.
That's what the role of the seed is. That when you pass the seed, every time you are going to get the same information.
Yeah. Okay.
Getting it? So when we do the data
Sir,
splitting, yeah, tell me.
install this AD test and not test packages.
You want to see the package?
Yeah.
This is
I'm not able to run it. I think the package is not installed in mine.
you need to first run the library dot this one and then do it.
I tried it.
So did you run install dot packages, not test and this?
No, I tried library dot the hashtag one.
You need to first run what you need to do.
Install
Dot
dot
packages and then write stats, and here also you do install dot packages and write
AD test or not test.
normal test.
Wait.
Could you please ping that code?
I will. So I will do one thing. Yes. Empty cars. Yeah, I'm going to ping it.
Inside seed, it can be any random number.
Any random number. So seeding part will discuss when we split data into train and test. So at that time, this seeding is very important. It helps us to split the data same every time. So we reduce the random chance or random bias we reduce. Here you can run without seed. So I think bad luckily when I run seed 1, 2, 3, 4, it is not giving random numbers. So just remove it and you can run it. I think the code which I pinged, that is working. Is it working for everyone?
Yes.
Now what I'm going to do?
Yes.
Every time I write the code, but never I write in the PPT. So what happened that? Just let me add it here. Yeah, so that it will be there for reference. Okay, so this is how we discuss about Shapiro-Wills. Wait, that is coming. Shapiro-Wills, that how it is helping. We just saw for Anderson-Darling test, that how it is happening. And the next is the case test. So similarly, the way we discuss about the other test, we'll do more detailing about case test in logistic regression, that what I mentioned at the beginning. So we'll know about this. It's that how it is useful to perform certain task and then check the value. We'll do that exploration there and on that part. Now here, what it's saying that is a non-parametric test, the way it mentioned here. So used to compare two samples or the sample with the given distribution. Here also you have the same. While testing for the normality, sample are standardized and compared with the standard normal distribution. So that's how the case test work. It does not work in a original shape. You need to convert that into Z score, and then you need to have it. Like I would say that if I showcase the mathematics, that how does it work, I would say that it is ks dot test, and here we need to pass some series, and then we pass something called p norm. So this is how the ks test work. And even if you check for the help for the ks test, it is part of again the stats library. You will be getting some example as well. I hope it should be. Yes, it should be there. So let me take it. I will explain from here only. It is slightly complicated. It's not as easy as the other test were. That's why I mentioned that I will do that into your the logistic regression part. We are going to check, like I'm going to produce random normal values 50. So let me do it. I will showcase what this X is doing. So it is producing some random numbers, and another is another function, that is y. Y is also producing some number. Getting it here. So I'm getting some numbers. Now I want to test that do X and Y come from the same distribution. So in that case, I'm using this KS test X and Y. And here you see we are getting some p-value. So the way we saw in the previous cases that how other tests work, the KS test help us to compare that are two distributions coming from the same way, or these distributions are not coming from the same family. In case test, we have multiple things like one sample test, then you can have the two sample test likewise. So you can run it and you can test it, that is it normally distributed or it is not normally distributed. Now, then coming to the theory part, theory is also saying the same story, that if data is given to you, you can check it that it's a normal distribution or it's not normal distribution. So this is another thing. In logistic regression, we'll do some more detailing about this, and we'll check that how case test is helping us to get certain assumptions that your data is following normal distribution or your data is not following the normal distribution. It will be slightly early for us here to check it. So I'm parking it for time being. In logistic regression, I will do some more detailing about the case test. But yes, as I mentioned that this is the code, how this code works, wherein you can pass some, saying that case test, you pass some value and you are looking for the p normal. Like here, if I pass simply y and run it, look here. So what I did here, in the case test, I pass the y, and what is my y? This is y is what we just produced for normal distribution. So look here, in previous case, we use this y, and I say that I want to have the random normal distribution, 100 data points with 0 mean and 1 standard deviation. On this only, I run this case test. So I said that I want to run the case test on y, and I want to check the probability for normal distribution. That's what the p norm is, the meaning of that is. And look here, you are getting this p values. This p value is very small. That is indicator that this data is coming from a normal distribution. Is that clear?
Sir, I'm not able to install this. case test, which is not available for the version 2.0.
So, did you case test is part of your stat library, stats. So, are you able to install this stats library?
Yeah.
Then it's still. Can you do one thing? The way I run this help and case test, can you run this and see that what the message is coming?
Case.
Just run it.
Okay.
It is important for me to check the message, that what message is coming.
Case.test. This one, right? The one you have typed. Did you ping it in the message bar?
I'm saying this one. I'm going to ping it. Run that and see that what the message is coming.
Okay. Package stats is in use and will not be installed.
What message is coming?
Package stats is in use and will not be installed.
That's what so this is not, the message is help is not coming the way it is visible to me. Is that?
The help is coming, yeah, that is coming.
This is coming?
The way it's visible, yeah.
Can you share your screen? I want to know that what message is coming to you. Do you want to share your screen?
Yeah, sure.
You are Abhishek? No.
Ara.
Okay, I'm making a presenter.
Actually, I'm getting this help message. I was not able to run the formula.
You want to share your screen?
Yeah, sure.
I think in past also around there was issue for you to install the package, correct?
No, I don't know, sir. It was working fine before.
Okay, it was working fine. So did you run install.packages? No, this is not case test. Install.package is stats. So in line number 53, you need to write stats. Oh, stats. Yeah. Now run it. Do yes. Yes, do it. Also do yes there. Oh, it is going in.
Coming again. Should I close and reopen?
I think you should do. Close it.
The same issue I am facing, Professor.
Okay, so I ping in the chat that your command is going to be install.packages stats.
I tried that, but still R is keep on restarting.
Yeah, same issue.
Okay, wait. I will tell you. Say no. Say no. Say no.
I am also facing same.
Warning. Package
stats is in use. Will not be installed.
Can you run line number 54? Write stats, not the case test. Yeah, it's done. Now you run line number 56. Yeah. AD test could not. Okay, it was not AD test. Your command here is going to be ks.test. Ks. Wait. I'm going to ping you in the chat. I think you people are trying something else. I pinged in the chat. So you are trying to run case test or you're trying to run something else?
Case test.
So write case.test.
Okay.
And this is fine. Empty card displacement. After displacement, no, wait, that's fine. After displacement, put comma inside bracket, comma. Okay, and after comma, you need to write in parenthesis p norm. P small p norm. P norm. In parenthesis, as I mentioned that in inverted comma. Now run it. Fine. Warning, we are okay with warning.
In case dot test, tie should not be present for case test.
Okay, wait, do one thing. I'm going to ping you the code. Do that. I think you are
Okay.
running something which may not work. Wait. Now I ping that in the chat. Can you try it? See in the chat. Just copy it from me. Now run it. Run this only 2 lines, 68 and 69. Yeah.
Okay.
Run it. You're getting it.
Yeah, got it. Yeah, got it.
So you need to listen what I'm saying. If you at the place of package you are installing the functionality, that won't work.
Actually, I did one by one. First, I installed stats, then I changed it there itself.
Fine. I ping everything into chat. If you want to take something from there, you can take it.
Okay, thank you.
I think it is done for everyone. Is there anyone else who is facing the same issue?
Yes, Chinmay.
You are facing
Now
the
resolved.
issue?
It's resolved, Chinmay.
Okay. Perfect. Then I'm sharing my screen.
Chinmay, I'm not able to. It's saying restarting every time.
That's what I mentioned. Do not start every time. Say no, and run library.
Okay.
I think the same challenge Araf was also facing. So say no and run the library. Library starts, and after that you run the code which I pinged.
But it's not installed.
Do you want to share your screen?
Yeah, sure.
You're Stanley, correct?
Yes, Stanley.
Wait. Yeah, you can share your screen.
Yeah. So this
Say no, say no, say no, say no, say no.
Okay.
Okay, that's done. I just pinged something in the chat. Can you go to the chat?
Yeah.
When Araf was doing, I pinged something.
Okay. Okay, the last one.
Take it. Paste it here. Yes, run it. Yeah, you are getting.
Oh, yeah. Thank you. Thank you, sir.
Is there anyone else who is facing the same issue?
In my one doubt, for the same code, we are getting different values for P. P value is different for each of us.
That will again, because it's coming by normal, the random. Okay. So do one thing. That's for the reason that I initially set some seed so that everyone get the same value.
Okay.
Got it? No worries. I think that comes because it is everything coming random. So for a randomness of the data that is coming. But the requirement is that we must get something. If you are able to get some output, then it is fine. That's fine?
Okay.
Now, that's what I explained that's what even given here. Now, so I would suggest that go through, read it slide.
Chinmay, one question regarding Kolmogorov. When the p value is less than 0.05, you told it's a normal distributed.
No, for in all the cases, if you are getting value which is less than 0.05, that is indicator of like
Not non.
wait. It is for the case test. Just a moment. Just a moment. Because different packages has different Python and R, they have the different understanding, the way it is developed. Let me also revalidate it.
Okay.
I'm not able to see your screen.
Oh, my screen is not visible? Okay.
No, sir.
No.
Yes. Now it's visible.
I was checking that what is the hypothesis for case test here. I think I need to go to the documentation. What would I suggest? That we run that how case test is run. When we come on the logistic regression part, we'll do some detailing. So just park it for time being in terms of hypothesis. There we'll check that how the hypothesis is and how the output is coming. This is slightly tricky. It is not easy as your previous two tests are. So just park it for time being. Because in documentation also, it is not given that what is null hypothesis for R.
Is it like it will happen for a lot of tests, or is it only for case test that p-value?
No, I would say one thing, that usually it so happen that majority of the statistical interface reject the normality if value is less than 0.05. Getting it?
Right.
In case test, though the data is normally distributed, it's coming less. So I need to check that the way the R package is written, it is considering reverse or how the hypothesis is. That I will confirm, and then I will let you know that what is hypothesis. Because here those hypothesis information is not given. I will check that. I will check that and confirm. But that's a good observation that here p value is coming, which is less than 0.05. It's a very small number.
Hello.
Yeah, tell me.
Chinmay, what's the significance of D, A, and K in these tests, like case test?
I will say one thing, that the way your all three tests are performing, there are certain mathematics. And you remember we calculate chi-square value, fine? And for chi-square value, we look into the table that value is statistically significant or that value is not statistically significant. So the way we calculated chi-square, similarly for Anderson, KS, or Kolmorov-Smirnov, there are certain calculations. So that value is coming by those calculations. Like here, this D value is coming from that calculation. Corresponding to this D value, a table is already inbuilt, and that table is giving us this information. So for us, this is what the value we need to check. This D is coming on the top of certain calculations. If you want to go to the mathematics, that mathematics will have its own limitations.
Understood. Likewise,
going forward, you will be getting many tests wherein we are not going to the mathematics. As I mentioned that this is the applied data science, wherein we are going to learn the application part. We are not going to deep dive into the statistical or mathematical calculation, especially in the test scenario, which is not too much of prominent. Like for Z-test, T-test, ANOVA, or chi-square, their calculation was required. For case and Hove and all, these calculations are not required. We need to manage by looking at the output here.
so that means these are the these values don't reference anything, like if it doesn't talk about any data.
No, I would
in
say
term of say
no.
that.
I won't say that it is not. Like if I go back, I will show you the equation that may give you some idea. If I talk about Shapiro-Wills test equation, I will Google it and will show. There are some mathematical calculations. So there are certain calculations, it's not so. So this W value is coming out of this calculation. Getting it?
Yes.
So there are, for everything, I think it's good that we take for this one, the other one, that may give us idea about hypothesis, like your Kolmorov-Simronov. So just a moment. So every test has its own equation, and if we go behind those equations, that will be like PhD in data science. Like the way I mentioned that here also some calculations happen, and on top of that this k value is calculated. Again, this k value is coming from some different calculations. It will be too much. I hope you people are getting the context.
Yes.
So at this stage, it is suggested to not do the deep dive to that level. Okay, we need to know that how the application happened for case test. That's what I'm explaining. Now, in the case or even the other test as well. In the case test, I need to check in our documentation that how the hypothesis is written. So is it reverse in terms of hypothesis, or it is the similar way? That I will update you. Now, after that, I am coming to this one for the normally distributed test. So we had discussion about Z test, 1 sample, 2 sample, even the T test also we did, and we did ANOVA. The next is coming for Hove test, that is the homogeneity of variance. So homogeneity of variance is one of the prerequisite when we talk about some of the machine learning algorithms. So there are certain assumptions wherein, like in linear regression, one assumption is that your data has that follow the homogeneity of variance. That means variance in your data should be homogeneous. That's what it says. So those are, I would say, some of the conditions, or I would say some of the assumptions for the test will see that how the homogeneity of variance is calculated. Now, let's go into the graph and try to understand that how it helps us to find or check the variance. And let's say that you are having you have your revenue figure, and this is the timestamp. Timestamp may be year 1, year 2, year 3, year 4, and these all years value are having 12-month data. Like you have 12 months data. And let's say that your revenue figure are coming like this. Let's say it is going like this. So now in this case, what we try to figure out that the variance which you are witnessing here in the first year, is it having the same variance in the second year? So we check that variance in the first year is similar to the variance into the second year. Is it there or it's not there? if it is not there, like especially in the time series requirement, if the variance is not same, you cannot use some of the techniques, and those techniques essentially consider this homogeneity of variance as one of the essential condition. So that's what we check here now. And this is usually happen when you have the series data, like we have multiple years information or multiple years data. That is one thing. Take the second context. You got sample from the multiple places. The way I mentioned that you are getting from Delhi, Mumbai, Bangalore. So you are given the 3 sets of the data. And now you are going to understand the variance. That what is variance here? What is variance at this place? So all the variances you are going to consider. And your plan is to do a employee level salary understanding, that you are going to develop some model which is talking about the salary, that to what education level what the salary is given. Now, and you are planning to merge all 3 data sets together, and on this merged data you are going to do analysis. Getting it? Now, if the variance of all the 3 different data sources are statistically significant from statistically different from each other, in that case, merging the data together and doing analysis is not the ideal way. We should do the differential analysis. You remember in the housing example, I mentioned that you have some houses in South Delhi and some houses in East or West Delhi. And if you are going to do some house price prediction, it is not suggested to club all data together and then make the model. You must have differential model. So in that case, homogeneity of variance understanding is quite important. I hope that is clear. Is it clear the role of homogeneity of variance?
Yes.
Now these are the assumptions. That's what I mentioned. And yeah, tell me.
I'm just checking if I'm audible. Yeah, sure.
You're audible.
I'm audible. Yeah.
Fine. So we test it that your data is following the variance. It is having certain variance, or your data is not having the homogeneity of variance. And for that, we have something called Hove test that essentially give us some information about homogeneity of variance, that how to calculate it. We'll check that in linear regression also, that will come. So this assumption is true for linear regression as well as for logistic regression. So in both the cases, we'll check it that your data is following the variance that is having the equal one, or it is not following the variance which is equal one. Fine. Now we have certain functions. I will tell you which those functions are like. One is called VAR test. I will be using going forward. Here I cannot use reason being, for that I need to create a multiple set of the data. So there is a function called VAR test. That is what the variance test. In this variance test, we need to pass your data, that which are the data on which you are going to work it. So there's some tests are there wherein we need to pass the datas, like the way I mentioned the Delhi, Mumbai, Bangalore. You pass the data, and that will give you the idea or information that your data is following the variance is the same, or the data is not having the variance. There is no variance into the data. So as I mentioned that this is the EDA session wherein we are learning these all procedures. Going forward, when I run the code, this everything is there. Once I complete this theory part, PPT, then I will land to the code part, and coding will do a lot of things there, and we'll explore that how the homogeneity is tested. Is there anything else that we can do on top of that? So we'll explore everything when I land to the coding part. Now, here some write-up about T and Z test is given. I would suggest go through by your own and tell me your understanding. I explained in the past about Z test and T test. Can you explain me that what are you getting from this slide?
Z test is for population and T test is for sample, and gen test is applicable for population greater than 30 and T test is for less than 30.
So there are two conditions. So first, look here. If saying that standard deviation of the population is known, yes, the what saying yes, and if your sample size is more than 30, go for G test, else go for T test. So if any of the condition is violating, then in that case we need to go for the T test. So T test is something which is the ultimate solution. That difference we know. That's good one. Now, then here it is calculating the Z value, how it is calculated. So x minus mu divided by the standard error. Now, if you remember, I explained that for the Z value we divide with standard deviation, but here it is talking about the standard error. Okay, what is standard error? So look here, your standard error look like standard deviation divided by the square root of n. This is the formula for standard error. And the way you get information from data, so in a problem statement, if the standard deviation is given and sample size is given at 30, and if it is asking to calculate Z value, use this formula to calculate Z value. I will tell you one thing, that from where this formula is coming. Okay, I will give you the mathematical relevance that may give you some idea. Let's say that your population is looking like, let's say it's a population which is, let's say it's a normal, and the mean of the population is, let's say your mean is going to be 5, something I just wrote. From this population, you took a sample of 10, and this sample of 10 is looking like this, wherein mean is 5. Okay. So now in this case, understand it clearly. Reason being, this is a concept. I'm saying you're taking the 10 records. From this population, in the second time, you are going to take 20 records. This is not better. Let's say you are taking 20 records. Again, your mean is coming as 5. Then in the third chance, so this is on the n is equal to 20. In the third chance, you are taking n is equal to 100. 100 samples you are taking, and your data is following like this. Is following like this, and this is having a 5 as the mean. Now you would have realized here that in the first case here, standard deviation is high. In the second case, again standard deviation is high. In the third case, your standard deviation is coming down. Now, that's what happened. So if you increase your sample size more and more, your mean may be same, but your standard deviation is going to decrease. That is a known phenomena. Getting it? That means if I say that your sample standard deviation SSD is function of population standard deviation divided by, as I mentioned that it is here, let me do a slight change because that will help me to put it correctly. So I'm calling it variance. I'm calling it variance, not standard deviation. Consider that in the variance term. So now it says that your sample variance is a function of population variance divided by number of records. If you keep increasing the number of records, your sample variance is decreasing. Yes or no?
Yes.
Now, in that case, from this equation, if I try to generalize, I say that sample standard deviation, I'm taking under root of both the side. If I take under root of both the side, so the variance under root will be standard deviation. So sample standard deviation is equal to the population standard deviation divided by under root of n. That's what formula I am getting. Is that clear? So on the theoretical, it is a theory part. You need to be careful. So on the theoretical front, if I talk about the standard deviation of the sample, which is equal to the population standard deviation divided by under root of n. That is how it is written. Got it? And if I go back to your slide is saying the same story. So how can we write? So the population standard deviation, I can write like sigma divided by under root of n, I can write. And the moment we compute, this is, be careful, we are trying to approximate that how your standard deviation of sample is going to look like by help of the standard deviation of the population. So this approximation which we are calculating, on the technical term, we can't call it standard deviation of the sample, we call it standard error. This term is known as standard error. So we can write, because this is not technically the standard deviation, we are trying to approximate the standard deviation of sample by help of the standard deviation of population. Getting it? So that is the reason that in theory it is written SC is equal to sigma divided by n, square root of n, or you can say n. That is what given in your PPT here.
What does standard error actually mean?
Standard error is approximation of standard deviation for sample by help of the standard deviation of population. It is approximation.
Okay.
Getting it? So if you call the standard error, it is approximation of the standard deviation of sample by help of standard deviation of population.
Okay.
Got it?
Yes.
Now, that is the theory part, that how we understand or how we take it up.
Sir,
Yeah.
sir,
Tell me.
sir, we are talking about standard error of mean or standard error of regression.
It is not regression. I didn't talk about regression. I am simply
No,
talking
sir.
about
I
the
mean
standard error of the sample.
sample, or it is a different term like standard error of mean. It
That
is a
is,
different term.
see here, what, first of all, it is saying the error. It is talking about the standard error. It is, this SE is standard error, and this is the standard error of the mean. So from how are we calculating? We are calculating, like if you go back to the theory, here we are using the standard deviation. And how this standard deviation is calculated? This is calculated by mean only. So S, if you call it standard error or you call it standard error of the mean, that is the same stuff. But technically, that is approximation of the standard deviation of the sample. So this SC is, you can call it SCM, standard error of the mean. This
Standard
is,
error.
yeah, this is approximation of
Standard deviation.
standard deviation
Okay, sir.
of
Understand.
sample. Okay. Now
Okay, sir. Okay.
look at this unit. This unit will give you idea. So your right hand side is standard deviation divided by under root of n. So under root of n is what going to be? It's a number. Fine. Let's say that standard deviation is 50 and you are dividing by 5. It is going to give 10. 10. So this 10 is again standard deviation only. It is not a mean. If I say 10 rupees divided by 2, then it is 5 rupees only. It's not something else. It is only rupees that will come in rupees term only. Yes or no?
Yes.
So technically, the information you are calculating, that is the standard deviation only. It is nothing else. Reason being, your in the right hand side, standard deviation is divided by certain numbers. So its unit is going to be standard deviation only. But though it is approximation, that's the reason this term is given as the standard error. You can call it standard error of the mean. Clear? Now, that's what this theory part is saying. That while calculating the t value, we do the same task here. So that is, again, let's say that, as I mentioned, you need to be careful with the certain things, that the moment you are getting something by help of population, you need to generalize for sample. That's what we need to do. Getting it? Now, let's say that you are getting something from the sample. Let's say it's sample. Still, you need to find a generalized way, that the information that is given to you, the sample, is that a true representation of the sample, or that's not the representation. That's what we're doing here. So even that is the t distribution itself. Here, this, as I mentioned, that the t distribution is applicable when you are getting your sample size is less than 30 or your standard deviation of the population is not given. So even if you calculate the standard deviation of the sample, still you need to calculate the standard error of the mean, because that is how the generalized term is. We need to generalize it. So in both the cases, be it t, be it z, in both the cases you need to calculate it. I hope this is fine.
Yes.
Yes.
Now, then we are moving to two sample t-tests. So in previous case, only one sample was given. What if now? So let's look on the theory part, that what theory says. Or some of the examples that we tested in the past, that let's say that a CFL manufacturer is claiming the average life or the average life of the bulb is, let's say, 10,000 hours. You think you are taking sample, let's say the sample is going to be 29 sample size, and in that sample you got mean is coming as, let's say, 9,900 hours. Now then you are going to check that that what all the manufacturer is claiming, that claim is correct or that claim is not correct. Getting it? So be careful. You have two set of the information. The first set of the information is coming from sample. So this is coming from sample. And this is the other one, which is here. This is not coming from sample. This is a generalized value. Or you can say a claim, which your manufacturer is claiming. Now you are going to compare with this 10,000 to this 9,900. Your comparison is going to happen between this to this. That's how we are doing. Got it? In that case, you can calculate like, you can do like, let's say, x minus x bar, wherein you can take it, you can consider that x and your x bar is given, and you can do some calculations. Now, this is one scenario. The other scenario is, it's not the same. Let's say that you are given the two samples, like the employee of Bangalore, what is the salary of the Bangalore professionals, and it is of Delhi professionals. And in both the places, you are given, let's say, 25 employee information only. And then you are going to check that are the both samples behaving in similar way, or the samples are not behaving in similar way. Getting? In that scenario, what we do, we calculate here, let's say x1 bar. X1 bar is here, and here is coming x2 bar. So x1 bar is the average of the Bangalore employees, and x2 bar is the average of the Delhi employees. Getting? Similarly, we are calculating the variance, that what is the variance of the Bangalore people, and here also we are calculating the variance of the Delhi people. Getting it? And now, then we are going to put into the formula. Fine. So be careful. In previous case, the way we wrote like your x minus x bar divided by standard deviation and then under root n. That's what I suggested to write. That's what we did in the previous case. Here you can't do in that way because you are comparing two mean. So the same formula is written in this way. You are going to do x1 minus x2. Oh, wait. Let me simply write. Yeah. x1 minus x2. Then you are saying minus mu1 minus mu2 divided by s1 square, or s1 square by n1 plus s2 square by n2. So your formula will look in this way. Getting it? So the same formula, the moment you split it, it is going to look in this way. It's better that you call it, I'm calling it x1 bar and I'm calling it x2 bar. That will also be the good one because that is the mean. So when you have two sample t-tests, that is you are given the two samples and you need to perform this task, that formula takes this different route. And we'll do this two simple t-test in some of the examples. Once I complete this slide, I will run the code in R and we'll perform those tasks. But this is how your formula is going to look like. The same formula, the previous formula which I wrote here, this earlier it was standard deviation, I wrote here variance, and I took the under root of that. So technically it is also the standard deviation only. So these are the two formulas which are technically the same, there is no difference, but the first formula is on one sample and the second formula is on the two samples. Is that clear?
Yes.
Now,
Yes.
now then I'm going to, because what happens sometimes when you see the formula, it seems very scary. That's what I explained. That if you talk about the t-test, you are saying that x1 minus x2, mu1 minus mu2, and you are taking the values. That's how, and it helps us to do the comparison of the two samples. And if you look at the technical way that how things are happening, it is very similar to your ANOVA. So in ANOVA also, we perform the same task. So as I explained that ANOVA is the multiple t-test. So either the way the entire formulation of ANOVA is happening, that is happening in the t-test way only. But there the provision is in one go, we can compare the many test. Fine, so that's how the two sample t-test is written. We had discussion about ANOVA, that how ANOVA look like, wherein your null hypothesis is that, let's say we are talking about three different samples, so all three different samples are coming from the same set of the population. That means their means are going to be the same. But alternative hypothesis is no, at least one of the sample is not coming from the population. I think that is different from the others. Now, let's do, I think this part, is it clear? I hope this is clear because that's what we're discussing in ANOVA.
Yes.
Now, we are going to perform some tasks here. The same CFL examples and all. Just go through and tell me your understanding. What do you think? What type of test is this?
One sample t-test.
This is, it's not one sample. Okay, you can call it, but again, it's better that you term it better. That I explained about lower tail, upper tail. So that will be the better way to ask it. Though it's one sample, of course, one sample is given, but what type of this? What is null hypothesis in this case?
Greater than equal to 10,000.
Null hypothesis is greater than equal to 10,000. And what is the alternative hypothesis?
Less than 10,000.
That's what. Yes, that's what the hypothesis is here. And your mean is given, standard deviation is given, everything is given. We need to just pass the T formula. Got it?
Right.
And now, in this formula, again, it will take some time for you if you do manually. I will showcase. So when we are passing that into the value, we are getting this value is when we pass into the entire process. Do you want me to do it? Okay, let me run it quickly in R. That will give you some better idea. So we are going to calculate T. So I'm saying T is equal to, if you remember your X bar, how much was X bar? 9900, fine. And then your mu was 10,000, fine. And then it's saying that your standard deviation was given like 125, fine. Let me put that into here. This one divided by SQRT square root of your 30, what the 30 sample size is given, and I want to close it. This will be, I hope this will be my T value. Fine. Something wrong I'm doing. It seems something wrong I'm doing.
X minus X bar, you have done reverse.
This will be your X minus X bar. Let me. I think still that will not have that much of impact. No, that will only, your value will only come in terms of negative or positive. I think the previous one was correct. I will tell you, in mathematical provision, some wrong is happening. So let me write, I am saying SQRT, this is fine, and this is going to divide this. So I think 125. That's correct. It is minus 4.3818. That's correct. So this formula is correct. Okay. So the one which I calculated is coming as minus 4.38. It is fine. Like if T is equal to that value is correct. That is the T statistics. That's T value is going to look like. And for that T, we need to look for, wait, something is happening. This X bar is given, X bar minus, that is fine. Your 999 minus 10,000, that's what I did. That is perfect. And let me do one thing. 125 divided by SQRT of 30. It is giving this one and saying K is equal to this. I'm just validating, just a moment. So if I say this one divided by K, that is perfect. So this is your, what we are getting the T value. Got it? Now, at the same level of the significance, we need to check that for, let me go back to your T table, because now though I'm doing manually here without passing the functions and all, so I need to check it manually. Okay, let me go back to my computer and wait.
Chennai, lots of voice is coming. I don't know where.
What is coming?
Lots of background noise.
I don't know. Tasneem, you are saying, so people try to mute yourself in case you do not have any question. Now, look here. Then we are looking into the T table. Though we run the T table and your data is having, how many data points are there? 30. So we need to look for 29 degree of freedoms. So we are looking at the 29 degree of freedoms. Wait, it is so though it is looking in the one tail test, so I will tell you 29 degree of freedom, and we are looking at 95% of confidence. 95% of confidence. So 1.6991, this is the value which we are going to check. And be careful, once you are looking at the lower tail of the test, these all numbers are going to be negative. That's how we look into the table. So once in the T table, if you remember the Z table, values start from negative to positive. In T table also you have some negative T values. So the moment you see into the table in the one tail test, it's depend that you are looking into the lower tail, you are looking at the upper tail. That's what it's saying, that one tail, two tail. So if your one tail is upper tail test, then everything is going positive. If one tail is lower tail test, then in that case, this value is in the table, this value is going to be negative. So minus 1.699, that's what we are going to check. So my table value is minus 1.699. That's what is coming from the table. And this is what even your slide, I hope, is saying. That is minus 1.699. Got it? So your T critical from the table is minus 1.699, wherein the one which we calculated, that is coming as minus 4.38. So let me correct in this PPT. Minus so I'm writing here, calculated is minus 4.3 minus 4.38. It is going to be minus 4.38. Okay. Now from that context, just ignore this graph. Okay. And even I would say that ignore this graph also, and take this one. Okay. Now, so if you look here, your calculated value is minus 4.38. I will tell you. So I was saying that if anything outside of that is my selection region, anything downside of that is rejection region. Now the question is, what is this value? So this value is coming as minus 1.6991, which we calculated from table, and the one which we calculated, that is coming minus 4.311. So this value is less than, so whatever the claim manufacturer is making, that claim is not justified. So we are rejecting the null hypothesis. Is that clear?
Yes.
Now, that's how you can do the interpretation. The moment, see, going forward, it will so happen that we'll use some data and we'll run some t-test using that data, wherein we did not do this all manual calculations. So we'll do it in a better way. But this is how you can calculate. Now, this was your problem statement, which I just rectified, did some corrections. I will showcase some more scenarios. But I will do, I have some other examples to run the t-test or z test. but I'm waiting to first complete whatever is given on the Marticus part. Once that is done, then I will move to that part and I will explain something. I will let you know more. Now, then coming about the homogeneity of variance, that what we discuss, that is technically your F test. It's saying that F test is used for the result if the variance of the two samples are similar. The test statistics, it calculates something. If you remember, we calculated the ANOVA. So in ANOVA also we use F value, we use F test. So in ANOVA, the F test was calculated.
Yes.
Yes.
So it is saying the same one. Look here, it's saying that n minus 1 degree of freedom, m minus 1 degree of freedom with the null hypothesis. So just go through. Test statistics is F, ratio of the two sample variance. F follow F distribution with n minus 1 and m minus 1 degree of freedom. If the null hypothesis is true, else has no the central F distribution. So in ANOVA, what all the calculation we did? We calculated the F value. Here, it is writing the same story, that how do we use F test to figure out that your data is there homogeneity in the variance or the homogeneity of variance does not exist. That's what information is given here. I would suggest that go through, read it. That will give you some better idea. Is it clear or you want some further understanding? So we'll do some more on that. So I would suggest that do not think that it is only the place we are only learning the theory. We'll do much on top of this and then we'll figure out that how does it look like.
Chinmay, I have a doubt.
Tell me.
Chinmay, we said that for Z test, the previous, the example that you took. So when we carry out Z test, n is equal to or greater than 30. Here the sample was equal to 30. So why not take the Z test and why we took the T test?
That's the good question. I wanted to know that can someone answer this question? If I go back to the slide, previous slide, looking at the problem statement, can someone answer? So read this problem statement. That information is here only.
Can you please repeat the question once?
Please repeat the question.
We know the standard deviation in this problem.
So this is standard deviation of, now here it is saying that, it is saying sample standard deviation. It's not saying population standard deviation.
Okay, got that.
Got it?
Yeah, I got that.
That was the reason. That was the reason that we are doing it. Fine. Now.
Yeah, fine.
So that's what I mentioned, that those informations are there. Now I'm moving from here. We'll do some more that how to do it. Now, I will do something here. Okay, let me. I think you should not think that it is not moving in proper way. So let me run some code. I wanted to prove it by help of the code. for like homogeneity of variance and all. So just give me a moment. So I'm going to use a library. I'm saying library name is card. It's here. Wait. And let me run it again. Yeah, it is running fine. I'm creating a variable called size. Size is equal to, I'm saying C, and randomly some passing 25, 22, 28, 24, 26, 24, 22, 21, 23, 25. I will tell you why I'm writing so many numbers. 26, then coming 30, 25, 24, 30, 24. I'm making certain distribution, so I have certain ideas about the numbers. 28, 23, fine, 25, 24, 20, 22, 24, 23, again 22, 24, 3, 4 more numbers, 20, 19, 21, and 22. So I wrote some numbers. I will tell you why I did it. When I run it, I have some 30 elements I wrote. Okay. Then I am going to create something called another variable called location. Okay. And location is going to be C, and I am saying repeat. Location, maybe I'm saying Delhi, as I mentioned that Delhi, and I want this to be repeated 10 times. 10 times. That is done. Then again I want to repeat your repeat. I'm saying Mumbai. I hope spelling is correct. And then I'm saying I want to repeat again 10 times. Oh, wait. Something happened. That's it. Okay. Then after that, I am saying repeat, and this time I'm saying Bangalore, BN Bangalore, and this is going to repeat again 10 times. And that is great. Perfect. So I need to just ensure that my brackets, everything is proper. Yes, done. So I created location here. Fine. If I run the location, you will be getting that. This is how I wanted write Delhi 10 times, Mumbai 10 times, Bangalore 10 times, that I'm getting. Now, then I'm going to create data. So I'm saying my data is going to be data.frame, and I'm passing at the place of size, let me say salary. That will be better. Okay, so I'm saying salary, and I'm saying location. Okay. By help of that, I created a data frame. Perfect, my data. So if you see how my data is looking like, it is saying that there are 10 records from Delhi, there are some 10 records from Mumbai, and there are 10 records from Bangalore. Getting it? And let's say that this is a salary, maybe monthly salary in 1,000 and something. I got some data of the, what I say, the placers, that those who got some job, how essentially they are looking like. Got it? Now, once that is done, then I'm going to run the homogeneity test. That is data homogeneous or data is not homogeneous. So I'm saying homogeneity test. For that, I have one test which say that LEVEN Levin's test. Yes, Levin test, perfect. And then it is going to be, wait, it is going to be salary here, salary, and then I need to write tilde. So wait, my tilde is here, and then saying location. I wanted to check it. Okay, that is done. And my data name is, I'm saying that it is my data. On my data, I want to check. And the way I'm going to check how I'm testing it. So I'm saying that center, that CENTER, center is going to be mean. Okay, let me run it. Oh, CENTER, wait, living, oh, living dot test. This is living test. No, this is fine. That was not, yeah, it is coming. Got it? So this is what, by help of living test, we are getting this information. If you look at the p-value here, your p-value is greater than 0.05, which is indicating that there is no significance difference between two group variance or the three groups variance. That's what we are checking. So the null hypothesis for Levin's here for the Levin's test is that groups are having the equal variance, wherein the alternative hypothesis is no groups are not having the equal variance. That's what we tested here. That clear? Are you getting here? It is saying that homogeneity of variance. It is checking that homogeneity of variance.
Yes.
Now, so there are tests. That's what I mentioned, that this is slightly
Chinmay, could you please repeat what is that PR and F that I could not understand?
Which one? Which one?
The PR is
This
greater
one.
than F. That part, yeah, that whole part.
Okay.
Actually.
Now, if you remember in ANOVA, we got something like this only: degree of freedom of numerator, degree of freedom of denominator.
Yeah, right. Yeah.
And
yeah.
we got some difference, division we got the F value. And corresponding to that F value, this one, we are looking into the probability table. What is the probability of this to be? So here, your probability value is coming as 0.57. And according to null hypothesis, if the probability value is less than 0.05, then we reject the null hypothesis. And here,
correct.
And here the null hypothesis is that your data is coming from all the three data points like Delhi, Mumbai, Bangalore having the equal variance. That's what we are assuming. Got it?
Okay.
Now, let me, because sometimes it so happens that we are explaining the theory without running this practical relevance. We do not understand that what technically is going on. Wait, let me add that here. So I'm saying insert. Wait. Done. That's what we did it. So now you read the write-up which is given here. Are you getting it? Is talking about the Levin's test here? the Levin's test and the Bartlett test. There are other tests to test the equality of variance, are Levin's test and the Bartlett test. I use the Levin's test. Similarly, there is Bartlett test as well. But Levin's is what we normally use. Now I hope this slide is clear to all of you.
Chinmay, what's the package for the car library?
Package for car library.
Yeah.
Wait. If you write, it's the install.packages cars. Simply write, because it's a library. So library name is same as the package name.
Okay.
Got it?
Yeah.
It's the same one.
No, I'm not getting it.
This library car you are not getting?
Yeah, there is no package called car.
Have you done install.packages?
No. Yeah,
So without that, how will it come? You have to run it. Or in case still you are, sometimes it so happen that we do not know that which package is required. So write help and write this Levin's test. It will tell you that this test is part of which library. If you run it, are you getting it saying that car library? So it is already giving the information. So run that install.packages car and then you will get it. So what I'm going to do, I'm going to ping it in case you want to test it. You can test.
Yeah, please.
I hope now it is working.
Yes, working for me. Yes.
Now, once that is done, that's what I explained. For the homogeneity and all that is done, that's a good one that we perform it. This is how your homogeneity of variance look like. It is saying that if your variances are, all standard deviation is same, all standard deviation is not same. That's how it work. Like in the second graph, it is looking similar. In the first graph, it's not looking similar. That's how your model try to evaluate. Okay. Now, chi-square, we had sufficient discussion. So I cover chi-square from here only, and this is what we did. Okay. Now, next is for us is coming non-parametric test. I think that will not take more than 5 minutes because there are only 2 slides. So it's better to complete it and then go for the break. In 5 minutes we'll complete because after break I want to run some code. So as I mentioned that in non-parametric, the one test which comes is the Mann-Whitney test. It's saying that if data is not normally distributed, then non-parametric Mann-Whitney test can be used to compare two sample. It is also called two-sample rank test. What does it mean? So let's talk about the rank test, and you will be getting some idea for that. Let's say that there is a training institute, and that training institute is training for, let's say 10 plus 2. They are training for CBSE and they are training for state board. Fine. In both the cases, they are training. Now, let's say that they have two batches. One batch is having, let's say, in CBSE, they have the 50 student. And here for the state board also, they have the 50 students. And they got a result. Let's say that the CBSE result 10 plus 2 came and And let's say that both are coming from, if I take some state, I'm talking with the Karnataka. Let's say for Karnataka, okay, both result came. So in CBSE, we are getting that those who are, this 50 students who are here, how many are getting the rank in, let's say, in 1 to 100, 1 to 100 in the state. So in top 100 rankers, how many students are coming from this 50 student? So let's say that there are 3 students, student 1, 2, 3. The first student rank is, let's say, 45th. Second student name rank is 79, and third student rank is, let's say, 87th. So out of the top 100 students, this is what the rank of these people are. They are ranked like this. Similarly, we are doing for here that in state board, we have list of the 100 top scorers, and let's say that this time there are 4 students coming from here. In this 4 student, how these numbers are 1, 2, 3, 4. I'm writing. First student is, let's say, number 36. Second student, number 55. Third student, let's say, number 78. And fourth student, number, let's say, 94. Likewise, these numbers are coming. Now, I need to test that the education quality for CBSE and the state board both are the same. This is what my null hypothesis is. My null hypothesis is that the education quality which CBSE is giving and the state, the institute which is providing for CBSE and state board, both are the same. Wherein my alternative hypothesis is no, both are not same. In this case, I am going to consider only this rank. What score they got, that is not my concern. I'm only concerned about this rank. Getting it? That's the reason that if you go back to the slide, it is saying that called two sample rank test. It only tests the rank, not the value. Is that clear? The concept which I explained, is that clear?
Yes.
That is what it called the, in a real life scenario in data science, we very rarely get this context. Fine, but it's good to know that what is the context, how does it happen, but this test is very, very rare. This is also known as the Mann-Whitney-Wilcoxon test. So people call it. So Wilcoxon also added something later on, but it has its own context we use in the different scenario. I will tell you another story I will run on the other data. Mann-Whitney test I will run here in R quickly in 5-10 minutes, and then we'll go for. So I am running. This is Mann-Whitney, WHITNEY, Mann-Whitney test. I'm doing command. And what I'm going to do, I have, as you know that in empty cars data, we have, I'm saying empty cars is equal to empty cars. I got that data, okay, and I have one variable that is called empty cars, and that variable, let's say mpg, mileage per gallon. This is what my data look like, and another variable is empty cars, and I'm taking another variable, let's say am. That's the variable, which how it look like. Okay. Now on these two variables, I'm going to run this Wilcoxon, what I say, the Mann-Whitney Wilcoxon sign test. That's what this Mann-Whitney is known as, the Mann-Whitney Wilcoxon test. That's how R has this interpretation. So for that, I have a command which is, I think it says WIL, yeah, Wilcox test. Perfect. And here I'm saying MPG, perfect, and using tilde, and then saying AM, and then saying data is equal to empty cars. I hope this is fine. Okay, so I think this is fine. It should run. Oh. Warning is fine. That's no worry. Now, this is what I'm getting the p-value. So I'm getting some p-value. Now here at 5% significance, we conclude that the gas mileage data of manual and automatic transmission cars are non-identical in population. So here we are rejecting the null hypothesis. And what the null hypothesis is? It's saying that you remember what I did. One is my MPG is mileage per gallon, and the second is car. So the car is my the petrol car or the gas car. That's oil car or it's automatic or sorry, it's automatic or it's non-automatic, manual or automatic. That's what the VS variable talks about. I wanted to check that is the mileage for automatic and manual is same or it's not same. That's what I checked here. My null hypothesis is that no, it's the mileage are the same, but alternative hypothesis is no, miles are not same. That's what I'm getting the p-value here. I hope that is clear.
So whenever we are running this test, every time we are getting the alternative hypothesis or null hypothesis remarks in the test itself.
You're right, because that's an indicator that how this formulation is built.
Okay.
That remarks come because on the different, I would say, packages or different interface, these algorithms are written differently. Got it?
Right.
That's why that remark is important for the user to understand that from which perspective he or she need to do the explanation. Got it? Now let me go back to the slide. Here it's saying that discrete with two attributes like your petrol or diesel or manual, and the y-axis is your continuous or discrete anything like mileage, that may be anything. That's what the Mann-Whitney Wilcoxon test is. And here some write-up given. Just go through, you will understand.
Ping me the last code, no, please. Last one only.
Ping it. I hope that is working.
Yes.
Yeah, it is working.
Perfect. Now, so that's what here it's written. It is giving the same interface that it is very similar to your your ANOVA or t-test. So read this. The way you will be getting that it's very similar to t-test. In t-test also we check the similar stories, that if the two samples or the multiple informations are given, are those coming from the similar population or those are not coming from the similar population. Just go through, you will get the meaning. So now it depends that the way I mentioned that we have multiple tests are available. Depending on the data compulsion or depending on the conditions, we need to think or we need to figure out that which test we are going to use. But yes, technically we have solution for almost everything. Clear?
Chinmay.
Yeah.
Yeah, actually, what I feel is, there is so many testers and so many, this tests are there. It's little difficult to remember for each and every time that, according. So, is there any way to, remember all this that we have to mug up all this thing?
No, it's not mug up. The moment we land to the technique part, everything will be crystal clear.
And you know what, since last 3-4 lectures we are doing only the theory part, so now I am lost in between, like I don't know also whether I remembered the first theory class or not, whether it will come in front of me and then I can remember, then I don't know. But right now I'm feeling very blank because so many things are together, so many tests and so many things are in our mind right now.
Yes,
I
same
don't know
with me.
about others.
Tell me, that is same with me too.
I will say one
Yeah.
thing. I will say one thing, that whatever theory we discussed, didn't we run some data to get or validate that how the output is coming? So there are two
No,
things.
not for everyone.
So that is
Not
not
for everything.
the theory. Okay. So we run the theory and we run on certain data and got the output. Now the question is coming that where are we going to plug in? So the plugin will
Right.
happen. The plugin will happen the moment we start the techniques. So every plugin is going to happen in some techniques.
Okay. So maybe at that time we'll realize that okay, now maybe we can connect the theory part and practical part. But right now, though, I'm feeling not that confident after attending so many theories of this.
So just wait. The moment we start the linear regression, you will be getting a lot of dots getting connected.
Okay.
But in
Sure.
true sense, the theory is what we call wherein I'm only explaining the slides that look what is happening. If I do not run the code, so you can say that the combination of theory and code. Do not say only theory. Yes, theory and code is there. Application is not there. So we have not yet landed to the application part. Application will come when we start doing some technique.
Yeah, right now, everything is, mixing with each other.
So
let's see then.
Wait for the technique. When the moment technique starts, slowly things will get connected.
Yeah. Sure. Let's see.
Chinmay, another suggestion, like a small help also from like a request, like if there is some like a table or anything like we can use or we can refer to, which says like for this type of problem, this we have to this table, this test we have to
Something handy you are saying.
something like that, like a data sheet or something like that. I'm not sure, but
I think if you are going to get anything like that, that is not going to be a kind of universal truth. That's what the challenge is. So if you talk about something handy wherein you can refer it, that may not be effective. The effective way is to get the problem statement, try to solve it, and then understand that in which direction it is moving. I have many things I can share, but again, that will create another level of confusion.
Okay.
okay, fine, Chinmay, as you suggest, we'll go.
I will see. It so happened that you will be getting those table, everything, mostly from the academics. In academics, people focus more about the theory. It is not the applied one. So what we are doing here, we are going to learn the applied data science, wherein a problem statement is given, and we need to apply what all we learn. So those academics has different requirements, and applied data science has different requirement. So I would not suggest to have anything handy or ready.
And sir, sir,
Yeah, tell me.
yes, sir, when we go through the any technique, at that time the points are coming. At that time, can you please revise the one things
Okay,
at a time?
I will just for to give you confidence, I will showcase one thing. Okay, that may give you some idea because we discussed lot many things. Your next technique is going to linear regression. I will show you the slides. You may recall many things that were discussed today. So just give me a moment. Like start from the formula, your covariance, everything we are going to calculate. In previous class, we talk about the how the correlation coefficient is calculated. Things will be repeated, and then I will come back to some of the theory part we just discussed, some of the assumptions. I think you will get the better clarity. Like your f value. So what is the application of f test? That will come here. So in linear regression, you will be able to call it that from which context f test is used. Now look here. Wait. Here we are talking about the QQ plot, that how it is useful. So this is one assumption. Here it is talking about the homoscedasticity. In that case also, we use homogeneity of variance to answer certain questions. So your two assumptions are coming. Likewise, many things will come. So everything that you are discussing or we discuss as on date, some or other form, you will be getting that application is going to take place. So it is not only the theory. Now the question is, if I'm going to start linear regression, and if I say that this is what the homogeneity of variance is, this is what the F test is, how will you understand what is meaning of that? At that time also we'll recall that look how the F test was and how the application of that F test is going to happen. See, I have to start somewhere. It is like circle. So on circle, you start anywhere, you need to follow a complete loop. So until and unless the complete loop is not completed, I think this disconnect will be somewhere here and there. That we learn something in theory, how are we going to apply it? It will be there. I hope you people are clear.
Yes.
It will be there. So I would say that we are only talking about we are just setting it's a kind of warm up exercise. We are just setting the context so that the moment we land to the technique part, we understand easily that what is happening.
Okay.
And it is technically, it's not only theory. With theory, we are running some code to get those outputs. So the requirement is you learn the theory, you know that how that is written in the code form, and you get the output. If that is done, then we are on the track. But if you're not able to understand that what is explained in theory and how code is written, then there is issue.
Chinmay, what I wanted to ask is like there are a few problem statements in the LMS. So we'll be doing those in the class because when I asked the coordinator once when this class started, they said that those problem statements or the in-class assignments that they show in the LMS will be done in the class itself. So are we going to do?
Yes, some of the assignment we did in the past, and here for this exercise, we are essentially going to perform some assignments. So if I go back, like your EDA, so there is something called in-class exercise. We are going to perform it. Wherein some problem statements are given, we'll solve it. That's what I am planning to do post break.
Okay, okay.
Got it? It is there.
Yeah, thank you.
It is there. We'll do that. Fine. Now, with that, we are going to have break. So it is 6:30 today. We are slightly late for the break. Let's try to come back by 6:45. Fine.
Okay.
Chinmay, like I can ask one question. Like, what's the similarity between Fisher test and F test? Are these the same?
Hi all. Am I audible? Can you hear me?
Yes, Chinmay, you are audible.
Okay.
Yes.
Now we are going to perform some task, and for that it is essentially for EDA, wherein one data is given to us. Okay. I will do one thing. First of all, I will showcase the data, and then we'll perform some tasks. Now, this is the data given to us, wherein it is saying that house ID is given, house type is given, and it is saying that distance from the street, that how far is house from the street, carpet area, house condition. So if you see here, house condition is ranked. So on a scale of 1 to 9 or 1 to 10, it was ranked. Then what were the built year, renovate year, number of bedrooms, fireplace, garage size, garage area, year sold, sale type, how this house being sold, like through the contract agent, new agent, likewise, and what is the sales price. So one data is given to us, and there are certain problem statements, certain questions are given. Depending on our understanding, we are going to answer those questions. Now, then I will go back to data definition. So try to understand that it's saying that we have ID, which is unique identifier. Then we have house type. So there are 9 types of house, 1 story old house before some 1930, etc. So this is one house type variable is. Distance from the street, it's saying that distance from the street to the house, how far is from the street. Carpet area, house condition. So house condition, as I mentioned, that there are 6 conditions starting from poor to excellent. Built year, renovate year, number of bathrooms, fireplace, number of fireplace in the house as. Garage car, number of cars garage can accommodate, that how big the garage is. Carpet area, year sold, sale type, sale price, and zones, in which zones it is coming, like residential, agriculture, commercial, residential area on hill, or residential area near to sea, something. Utilities, like only electricity, no gas connection. Gas, electricity and gas connection, all public utility, including garbage, cleaning, everything. Next is coming landmark, near to the landmark objects like school, college, etc. So like if I reopen the data, it would be getting here that it would be some, okay, that information is given. Let me close it. Like here, consider this one. That's how the zone, etc. is given. Utilities, how it is going to look like, and the it is still utilities only. So the way it's given here, saying that in utilities you will find that is there any landmark, the public utilities. So that is coming under the utility variable, the one we just saw. Now, so this is what the data given to us, and it is saying to perform certain tasks, saying that do the pre-processing, do some data transformation, or do some feature selection, and showcase. It's more like a data is given to you. You need to perform some EDA and generate some meaningful insight using this house price dataset. So no specific problem or the question is given. You need to get the data and then perform the task, that how it is looking like. I hope problem statement is clear.
Yeah, it's clear.
Okay.
Yes.
Now we are going to perform some tasks. So I was just expecting everything is stored. Yes, everything was stored. I'm saying that test. I just wanted to save it so that in case I need it in future, I can retrieve it. Let me close it. I am coming to solution. Yeah. Will perform some task, that is data manipulations and preparation. Oh, it was here only. Done. Wait. Perfect. Now, what I did here, I will tell you. One by one, the moment we perform some task. Now, first of all, if I run getwd, what will I get? We wrote something on line number 13. If I run getwd, what information I will get? Durga Prasad, we are getting some disturbance, so it would be good if you mute. Yes, this will give us some working directory information. We are getting... Someone saying something?
It will give you present working directory.
Correct. So if I run it, I will come to know where my current working directory is. In my case, it is somewhere else. In your case, that may be somewhere else. Are you people getting some disturbance sound?
We are getting some discussion. Durga Prasad, please would you mute your mic?
I don't know. From
So,
whose...
sounds coming inside the Durga Prasad.
Yeah, so Durga Prasad, if you hear us, I'm just checking that whose speaker is Vidhi. Vidhi, do you have any question to say? I'm going to put on a mute, Vidhi. In case you need, you can unmute and you can ask the question. I was checking that who all are not muted because we are getting some sound. Okay, now it's good. So we got the working directory. We set the working directory. Okay. In case you want to put somewhere else.
Chinmay, how do we set the working directory?
Okay, that's again a good question. So the moment we are running getwd, we know your working directory. Okay, let's say that currently my working directory is somewhere at this place. Very long extension. If you look at now, if you want to set your working directory somewhere, let's say on desktop, at your choice. So if I go to desktop, and in desktop, let's say I want to put in this scrap folder. Got it? So what I'm doing here, I'm taking the URL of this scrap and then coming here and writing setwd, that is your set working directory, and here you need to write your URL, that you are passing that path, that where that path is. So technically this is path. This is how we set the working directory.
Sir, why are you given so many backslashes?
Now there is this default slash R does not understand. So in R, this natural slash is sign of division. So it does not understand. So in that case, you need to, I think it's not understand. So what would is suggested in that case? Do the double slash.
Okay.
Got it? So if you do not put the double slash, you will be starting getting the error. Else, you can do the reverse slash like this way. This also R understand. But
Okay, sir. Okay.
but a default one does not understand. This is how we set the working directory. I hope this is clear to everyone.
So it is for a permanent or for a particular
This is only for this session. The moment you are working on this one, for this session, until and unless you do not change it, or until and unless you do not close your system, this will be your working directory for this session.
Okay.
Got it?
You can also go to sessions and select manually, right?
You can go to
sessions on the top. Session.
You can go and do it. There are many ways, but I would suggest that you're saying from here you can do. There are many ways, but I would say that this is the ideal way to perform it. Even if I go to files, from files also I can access everything. Getting it? There are many ways, but I would suggest to use this way, wherein we are writing some code and getting the work done. Done?
Yes.
Now, I'm just putting on default one so that it is not going to change. That's fine. Now, after that,
GTWD is to import the data.
GTWD is only to set the working directory. Okay, it is now for importing the data and all, we need to write read.csv or write.csv, depending on what are we going to do. But here, at this space, I'm only specifying the folder. I'm not saying any dataset name.
Got it.
Got it? Now, in my data, if you see, if I go there, in datasets, I have two datasets. One is the house data, wherein those housing informations are given. And the second is called the house feature data, wherein some features are given, like zone, utility, landmarks. So two data are given to me. Getting it? Now, but in both the data sets, I have ID is common. So my one problem statement is saying, that's what I wrote here, that merge database on ID. This is an example where you have two separate data sets here, but a common column between the two data sets. Using the common column, we are merging two data sets into a single data set. So what are we going to do? Two data sets are given to us, and there is an ID which is common in both. So using that ID, we are going to merge both data set and creating a single data set. So now this problem is clear, that what are we going to solve in this case?
Yes.
Now, then what I'm going to do, I'm going to read both the data sets, like house data and house feature data. So there are two data sets. House data we saw, wherein we had house feature data, wherein we have ID, zone, utilities, and landmark. And second is the house sales data, wherein we have this house related informations. So we have two data sets. Using these two data sets, we are going to merge together and creating a new data set. So look how merging is happening. It is very similar to SQL query, wherein we run certain joins. So my function is merge. I am passing my first data, sales data, and the second data, feature data, and saying by ID. So by is my common variable. By help of by, we pass this common variable ID. So by is the command to work on the common variable. So what it will do, corresponding to the house ID, it is going to bring both informations together, information from both the data sets. I hope this is clear.
Yes, sir.
Now, once I run it, it is going to create a new data set called house data. So look here. Now, house data is created, and look here in house data, Let me make it bigger. In house data, there are 17 variables. Okay, wherein in the teacher data I had 4 variables, and in house sales data I had 14 variables. So when I add 14 plus 4, that is going to be 18. But why it is coming 17?
There is one.
Because ID will merge.
Yes. So ID is common. Correct?
Is common. ID is common.
Right.
Yes.
That's what is happening here. So now if I open my house data, this data is having all the informations, like including your zone, utilities, like in which zone it's coming, landmark, near hospital, schools, university. Look how school is written. I don't know from which place this data is, but in some places people like school like this. Fine, no worries.
Sir, I have a question.
Yeah.
Maybe it won't be a relevant question, but for example, in read.csv, the first data set, the unique IDs observations are same, but the headings are different. How can we merge in that case? For example, in one data set, it is saying employee ID, and in other data set, it's some other name, variable name is different, and the observations are same. So how can you merge in that case?
You need to rename it. So it so happened that I will tell you the reason. Let's say that you have a data. Let's say data set name is ABC. Got? And in that data set ABC, let's say that variable name is written something else. Okay, and you want to convert that into, let's say, employee ID. So you're saying EMP ID equal to, you need to say ABC. Okay, and let's say that this is given something else. You want to rename that as employee ID. So let's say that in original data is given like XYZ. Getting it? So what it will do, it will rename this XYZ as employee ID, and then you can run this. So the way you want to rename, you can do in this way. Else there are many ways. Rename option is also there, but you can try this method.
Got it.
Else write the SQL queries, because in SQL query you have option to pass the differential name. Like I think, is there anyone who is coming from SQL background?
I had experience long back.
Okay, so I'm just going to reiterate. SQL has best part. It work on the variable name as well as it work on the variable position name as well. So if you are writing the SQL query, in that case, keeping the variable same name into both data set is not compulsory. Getting it? So I'm saying that the moment you are going to use SQL, this task will be very easy.
So you can give a dummy name.
No, I'm not saying dummy name. I'm saying the variable position. So like first column, second column, third column. So despite the name of the variable, you can pass the column index, and you can also do it.
Okay, got it.
So once the SQL comes, we'll talk there, but this is how you can rename it. Got it?
Do we to run some command to change into SQL mode or something like that? Like in SAS, we write one line on the top, like SAS.SQL, something like that, and then we start SQL coding. Is there something like that also in R?
There is. So I would say that you can integrate SQL queries with R, SAS, Python anywhere. Okay. So though you are talking about SAS, so just for your reference, in SAS we write like proc SQL,
Yeah.
something. That's how we do. So that is a trigger that how things happen. Here also we have ways, but that is, I would say that is too early for us. But yes, you can integrate it.
Okay, thank you.
Fine. So this is how we are going to merge it. So it is merged. If you see the structure of the data, it is giving you complete information that you have 17 variables, and this is how your structure look like. That is fine. We are not going detail into the structure. Going forward, we'll see that what all problems are given. Now, then we are going to run summary of the data. So summary of the data is saying that, let me clean it. So ID is fine. House type. Did you see house type is considering that as a number, but technically this is not a number. It is a type which is given between 1 to 9. Getting it? So we should not consider that as a number, but now your data is taking that as a number. Distance from the street is fine, that's a number. Carpet area is also a number, that is fine. House condition is also not supposed to be a number because it is a ranking on 1 to 6. Built year is number, that is very good. Renovation year is number, very good. Number of bathroom, it's a number, that is perfect. Fireplace, yes, it's a number. Garage cars is a number. Garage area is number. Years old, that is also a number. Sales type, it is considering as a categorical. And sales price is a number, that's fine. Zone is also considering as categorical, that is a good one. Utilities taking as categorical, fine. Landmark is taking as categorical, that is fine. So there are certain variables as per our understanding. Your data is taking that as number, but those are not the numbers. Okay. Now, then what are we going to do? Here it's saying that assign one unique identifier to each label. Like, is there in our data? Oh, wait. Okay. I will showcase what is happening. So there is a variable called carpet area. Okay. Look at this variable carpet area. That what is happening. It is saying that carpet area is factor. How can this carpet area be a factor? For us, it is looking like a number. I will go to the data and showcase. Look at the variable carpet area. In carpet area, we have some informations and some are NAs. Okay. Now, be careful. I just wanted to highlight that some NAs are written in NNA uppercase, but you will be getting some NAs are written in NNA lowercase. Like here. Did you realize it?
Yes.
That's the reason that while we are reading it, it is considering that as a non-numeric because it's getting some character variable. If NA is written like NNA, it would have considered that as a missing value. But if the moment it is written like NA small letter, it is considering that as a factor, not as a number. That's what happening here. So the moment I run the class, it is saying it's a factor. Now, there are certain challenges which I want to highlight here. That if you want to convert a factor into number, then the way is you need to first convert factor to character and then character to number. This is how the approach is. Directly, you cannot convert a factor to number. That's what we are going to do here. Now, then what I'm doing in my data, I just wanted to know the requirement that there are some NAs. I want to convert these NAs as missing value. But currently, due to the different ways how NA is written, it is not considering that as a missing value. It is considering that as a label. So my objective is to bring that into proper shape. So for that, I'm going to convert my data, this carpet area, into character. And look what I'm saying. I'm saying as.character, I am passing which data set, which variable. And in left side also, I have the data set and variable. If I run it, and then I run the class, now it is saying character. So this carpet area is converted into character. Done? Now, from here, the story is going to start. I am writing a condition saying if else. House data, carpet area is NA. Be careful, I am writing double equal to here. Because this is a comparison operator, it's not an assignment. I am checking this condition. So I am saying that if house data, carpet area is NA, then I want to convert that. I want to write that as NNA in uppercase. Because this NNA is indicator of missing value in R. Clear? Now, let me explain you the logic. That what logic I am writing here that may give you a better idea. Let's say that I have data 35 NA 45 NA. So I'm writing a condition saying that if, let's say this column name is A. I'm saying if A is equal to NA, then I want to write that as NA in this form. Else, I want to write value as A only. That means if this is NA, small NA, then write as NA. But if this is not NA, then keep it as 35. So this logic will only work on those records wherein this information is given as NA. Now let me go back here. I'm saying that carpet area, if that is NA, then rewrite that as this NA. So you can see here this NA, the second NA which is coming in the blue color, this is indicator of the missing value. Else, write the same value which is there. So I hope this logic is clear to everyone. Clear?
Yes.
Now, at the same time, so this is done. So the first task I did. Then second time I'm saying that if it is written like NA this way, then also convert in NA. The reason being we just check that the values are written differently. So both I did. Once that is done, then let me run the summary. Okay. So before summary, I need to reconvert it. So once that is done, then I am converting that as a numeric. The way I explain that, first a factor need to convert it into character, and from character I need to convert as a numeric. That's what I'm doing in line number 53. So now I'm converting this variable into a numeric. That is done. After that, if you check the summary, it is saying that in your data, there are 49 NAs. That means in your data, now you have 49 missing values. That means this data is converted into numeric and your system is considering that as a missing value. I hope this process is clear.
Yes.
Yes. Yes.
Yes.
Now.
Yes, Chinmay.
Sir,
This is for missing values, right?
It is
To
for?
identify the missing values. Missing values, to identify the missing values.
It was to change NA, small NA and NA into a missing value.
Into a missing value. Okay, but NA is here, NA is missing only, right?
Yes, here it's missing only.
Okay, right.
Sir, if we forcefully change initially from factor to numeric, and then if we try to do if else,
no, it won't work. It will throw the error.
By NA, right?
It will throw the error. It won't happen. You can try. I will share this code. Without converting into character, you can try to forcefully do into numeric?
Because a small NA is a character type observation, so that's the reason it won't identify.
Yes.
Okay.
Okay. Chinmay, one more question. So can we have this data set for practice?
I will share with you.
Yeah, sure.
Sir,
I will share.
Chinmay, could you please share the code too?
Without data,
Yeah.
without data, how will you run the code? I
Yeah,
will
no,
share.
I'm. That is why
After you share the
We'll
data.
run later, sir.
I will
We'll
share.
just like copy and paste.
I will share. I will share. I will share this code file. I will share the data.
sir, if we have a data set and the column contain blanks, then the procedure is same or not?
No. So if the column is blank, so R automatically read that as a missing value.
Okay, okay.
Getting it? But here, what
Okay,
the
sir.
challenge is, someone has forcefully written NA. That's why R is not able to understand.
Okay.
Got it?
Okay, sir. Okay.
Chinmay, one more question. So if in the data set, in the missing value, it is written as NA, and if some blank, some are blank, then that will also converting into NA or what?
So that blank, if something is blank, first of all, it is very illogical that some missing is written as NA and some missing are left as blank. Understand, it is data science. It is not like Excel spreadsheet work. So in data science, the way we work, we extract data from some database, and database never do like that. First thing. In case you are still getting that, because what you said, that is a very hypothetical, but that never exists in real life. Getting it?
Okay.
No, but still you are getting that, wherein someone has forcefully wrote like NA, and there are some missing values. Getting it? So be careful. Be careful in that. In that way, NA will be read like NA, and the missing value. So it so happen that if there is a missing value and system is reading that as NA, so the moment you open the data, you can see that that NA is written differently in a slight, what I say, in the lighter blue color, in lighter gray color, that is written. So you can easily identify.
Okay. Okay, correct.
But that, I think, in data science, that never exists, wherein, yes, people do forcefully the way it happened there. So it is good for learning purpose, but in real life, that rarely exists.
Okay. Okay. Thank you, Chinmay.
No problem. Now, that is done. So I hope you people have idea that how we did till line number 54. Now, the question is that if someone is asking, can you calculate the mean of the carpet area? So I'm going to write a function called mean in line number 56. If I run it, I won't get the answer. It is saying NA. The reason being, in your data, some NAs are there. Fine. In that case, if you want to calculate the mean, you have to write this additional command. That mean house data and NA dot remove is equal to true. Getting it? If you write it, then only you will be getting mean for non-missing values. If your data
Chinmay,
is,
we have
yeah,
small NA is required or a big capital NA?
this one, NA.RN, this is
Yes.
the way it's written, small only.
Okay.
So does it take those values with NA? Does it add and divide those values?
No, that it ignores those missing values. It's only consider those cells which are non-missing.
So if there
Sir,
are,
it will skip the NA value.
It will skip the NA values.
So if there
Okay.
are 10 observations, 3 NAs, it will take only 7.
Yes.
All right.
So what is this T is equal to T means?
True. So you can write like this also. Okay. This will also give you the same answer.
Okay.
That's fine.
If false there, it will take NA values.
If
What if we give false there instead of true?
No, it will throw the error. So I will say that if you say na dot remove is equal to false, and if there is
Okay.
so in the above case, this is na in this scenario, na dot remove is equal to false. It is already true. Getting it? So na dot remove is equal to false will not, in this case, will not perform your task.
Okay.
Sir, will NA will be considered as 0, or it will not even consider that observations? I mean to say, for
It is
example,
not
in a
zero. It's not 0. So 0.
it won't.
No.
I mean to say, if there are 4 observations, and if one is having NA, then it would be A plus B plus C by 3.
Yes.
Okay. Thank you.
Let's do one thing.
So for this chord also, this NA dot RM remove. So we are removing that NA. That is why we wrote, right? NA dot RM.
Right.
If anything else value is there, then we have to add that.
What add?
Means here you wrote no NA dot RM means remove. Remove NA. That is what we are trying to say here.
Right.
Right. Okay. So if anything else is written instead of NA, then we have to write that. Like if false value is given, then false dot RM is equal to true. Likewise.
No, it's not the case.
Not like.
So
It is not a case.
NA dot remove is the function. Getting it?
Okay.
So it does not
The
mean
whole
that
is a function.
Yes, that is a function.
Okay.
So let's do one thing. So I'm saying that mean of, I'm writing 2, 3, 4, or let me do differently because that will again confuse. X is equal to C 2, 3, 4 and NA. Okay, I got this. Then I'm writing mean of X. Are you getting it saying NA? If I say mean of X and then say that RM dot remove is equal to true, look, it's given me 3. Can you calculate what is the average of 2, 3 and 4? It is going to be 3 only.
Right.
So I hope now you got how it is working.
Yes.
Chinmay, it is not considering 4 observation because there are 4 observation, 1 is 0.
Where is?
So average will be divided by 4.
Where is 4?
It is not 0. No?
Where is 0?
NA will be considered null value.
No, in NA does not mean 0. It is statistics. So missing value does not mean 0. Missing value is never equal to 0. Thumb rule.
So that will be not considered in the observation. If we have 4 observation, so that is not considered as observation.
Yes.
We have 3 observation.
Right.
Okay.
I hope that is clear.
Yes.
Yeah, it's clear.
Okay. Now, next is we are going to understand another variable, distance from the forest. It is saying that distance from the forest is integer. I wanted to run summary of this variable. So be careful. You can run summary for a particular variable as well. You can run summary at the overall dataset level as well as at the particular variable level. So it is saying that in your data, there are 46 missing values. Getting it? Now, then we are going to calculate mean. Same scenario. We are saying that mean house data distance from the street and NA dot remove is equal to true. So it will give you your mean. Oh, wait. It will give you your mean, right? 35.7797 is your mean. And the way we are calculating it, you can not only mean, you can even calculate the standard deviation as well. Like at this place, if I say, that's what I wrote here. So distance from street. If I write here, I am calculating standard deviation. So you can write the function standard deviation, and it is saying that standard deviation for distance from the street is this 20.56. And here also you need to write na dot remove is equal to true. Got it?
Yes.
Now that is done. Then we are doing on the sales price. So running standard deviation for sales price. Look here, it is saying that 13072 because sales price does not have any missing value. So look here, in case of sales price, even I run the mean, like if I run the mean on the sales price, I won't get any error because there is no any missing value. So it won't throw any error. But still, if you write na dot remove is equal to true, it will not have any impact in your output. Your output will be the same. So it is always good to pass this command na dot remove is equal to true. If there is missing value, then also it's fine. If there is no missing value, then still that is fine. It will still produce your result. So I would say that writing code in this way is a good habit. Is that fine?
Question.
Now, and these codes you need to remember. Then what I'm going to do? I wanted to run correlation between built year and the sales price. Right? Now, before that, let me run the summary of built year. And oh wait, what happened? It is saying that this is how your data is going to look like. Minimum is 1910, maximum is 1990. That's house, the year in which house was built. I want to run the correlation between built year and the sales price. That higher the built year value, that means newer the house. If the house is built recently, its year will be, in terms of number, years will be high, like 1990 is higher value with respect to 1971. Getting it? So I want to run correlation between built year and the sales price. And this correlation is coming hardly 4%, not very good. That means this is indicator that your sales price is not highly correlated to built year. Fine, there may be some newly constructed house, but price is not very high. At the same time, there may be some old houses wherein price is high. So price does not have any good relationship or correlation between the built year. Are you getting this message?
Sir, how can we identify there are the good correlations between the two variables?
I would say that we'll plot something called correlation plot, wherein in one go you will be getting correlation with everything. I will showcase. Not here, but in regression, in one go we'll plot something. We land to certain techniques, like I will showcase. There will be some correlation plot here. If I open it, you will be getting that how are we doing in the advanced technique. So look here. It is same. It is again housing data, sales price, total basement. It's bigger data. So look here. We are running correlation with each and every variable. So these are all correlation value. So we'll learn that how to create this table, wherein in one go you can see all correlations. But here we are running one by one to check that where your sales price is highly correlated. Clear? Did you get your answer? Now, sometimes it so happen that look here, I have the moment I run correlation between built year and sales price, it run perfectly. I am going to get the summary of another variable that is called distance from the street here. And if I run it, this is saying that in this data, I have 46 missing values, distance from the street. And if that is the scenario wherein there is a missing value in one variable, now I'm going to run correlation between distance from the street and the sales price, the way I did previously. I run correlation between built year and the sales price. None of the variables like built year and sales price didn't have any missing value, so I run the way it is given in line number 75. But if your single variable is having any missing value, so in that case, you need to use this command call add this additional column saying that use is equal to complete.obs. So what it does, it only considers those records wherein missing values are not there, and then only it's run the correlation. Is it clear? I hope it is clear to
Hello,
everyone.
sir.
Yeah.
Yes, sir. Is there any method to directly identify the which variable have more correlation between them?
That's what I mentioned. The Excel which I demonstrated that has the
Sir,
correlations.
but
Tell me. So if you want to see correlation with all variables, that will talk in linear regression. So we have code to perform. Here we are running one by one to check that how the correlation look like. But yes, we can run on the complete data. There are some prerequisite for the correlation run on the data. You need to split your numeric and categorical data separately. Then only you can run it. Got it? That's why I'm not doing here. That we'll learn in the next technique. Here we are running one by one. Now, so as I mentioned that, why are we using use is equal to complete.obs? I hope you people are getting the meaning that why it is happening. Is there any question on this part about line number 79?
Just to confirm, complete observation is to make sure only we are taking only the non-NA values.
Yes. Fine. The reason being, if I run the next line of the code without passing this use is equal to complete OBS, you will be getting NA. So if you look line number 79 and 80, the only difference is use is equal to complete OBS. So line number 79 will give me the answer, but line number 80 will not give me because there is some missing values. Clear?
Yeah.
No.
But I have one question. But here, why we do not use the NA removal kind of code, whatever we
See,
used before?
no. So different functions has different provisions. We can't use. That was mean. Getting it? So that was mean. Different function has different way to build it.
Okay.
Clear? Now, then what I'm going to do, I'm going to run some visuals. Like I'm running histogram on the sales price to see that how the sales price look like. So this is, it is coming in scientific notation. Just a moment. Yeah, this is how the sales price look like. So I just wanted to understand that is my sales price normally distributed. So for that, I am running this histogram, hist. And you remember earlier when I plotted the graph, my graph was coming with scientific number here at the bottom. So I am suppressing by this one. If you say option sci pen, that is scientific pen you are going to use, and say 999. So what it does, it convert your scientific number into the real numbers, which you can easily read it. That's what the role of line number 83 is. Clear? Then we are running the box plot to see is there any outlier in my data. It seems like good. Fine. So this is just like data validation, because this is my sales price is going to be the dependent variable. I think that's how the price is defined. Now, then I am running the structure str of sales type. This structure is saying that there are 4 types that how people are selling it. That's what even we check, that the contract agent, direct contract agent, something. I want to see the class. What is the class? It is saying it's a factor. I want to know the frequency, that in sales type, what are the labels and what is the frequency? Oh, wait. So this is, wait, it is saying, yeah. So this is what the line number 91 is saying. It is saying that in your data, if you talk about the sales type, there are 365 houses which been sold by contract agent. There are 387 sold by direct, contract direct, and 357 by new agent, and likewise. Is that clear? That's what the role of the table statement is.
Right.
Now, once that is done, then look here, I wrote table, and on the same table, the way I wrote in line number 91, I am writing pie. So what it will do, it will produce a pie chart. Getting it? And you can roughly estimate that numbers are quite similar to each other. There is no big difference. And in the same way, if we want to write proportion, if I write the proportion table, if I write this part, it is going to convert, like it is saying that 25%, 26%. It is giving me the proportion. Earlier was giving me, table was giving me the number. If you write prop.table, then it gives you the proportion. That's what the proportion is. Like you can multiply with 100 to get the percentage. Clear?
Right.
Now, then
Chinmay, you multiply by 100. It is where we have to write 100.
Okay. Now, first of all, you are saying prop.table. This is the command, and look here. It's saying prop.table. It is giving like this, and let me write here.
Okay, anywhere we can write.
It's not anywhere. Getting?
No, means at the end it is okay. That is, I thought we have to write in between prop table.
No. Here we are writing.
Okay.
Fine.
Yes.
You need to know that's how did I understood that here this is the place where I need to write. So that comes by practice. When you do the practice, reason being, this part of the code is giving something like this. I need to multiply with this only. That's why I'm writing this output multiply 100.
Yeah,
Okay.
I got it now. Yeah.
Now, then for the sales type, I want to know the bar plot, that how essentially your sales type look like. Like if you want to visualize in terms of bars, you can do it. And then again, I wanted to see bar plot proportion type. So you can add the, this is like bar plot, and you are adding a proportion, the way we added into proportion in the previous case. So depending on what is the type, you are adding percentage. So saying that close to 25% is contract agent, likewise you can get out the meaning, that what is the meaning of this. Clear?
Yes.
Is there any question on this part till here, what all we discussed?
No.
No.
Fine. So now I just wanted to reiterate that a lot of theoretical discussion we did, and some of the theories we are going to explore here to understand that what is meaning of those theories. Now, once that is done, then I am doing something. So what something I'm going to do? Here it is, some problem statement is given that see the data distribution using histogram command with other arguments, turn off the scientific notation to turn it on, set scipen is equal to 0, go through the histogram command in detail in Google to understand an argument, etc. So I'm just saying the command, but I'm writing here code. Now I'm writing a histogram, and how histogram I'm going to do, I'm saying on the house sales price, main, that is the graph name, is going to be the histogram. X level is going to be sales price. Y level is going to be count. Labels I'm saying true, that's how it is going to appear. X limit I am passing something. Y limit I am passing something. Saying include dot lowest is equal to true. We had this discussion. X is equal to true, color is equal to orange. Let me run it. Then you will get the complete meaning. Look here. That's what I wanted. So I'm saying your what the X label is going to look like, how the Y is going to look like. Labels I wanted, that's how the labels are. X limit, I'm saying that how the value of X is going to look like. Y is how it's going to look like. Your include, it's saying that lowest is true, that's how the values are there. X is equal to true, color is equal to orange. Fine. So now you can experiment the entire stuff. Like I have written here another code wherein I'm simply saying color is equal to orange. I'm saying histogram sales price, main is equal to house price, histogram, X level is equal to sales price, why is this? So let me run one by one. Then you will come to know that which part is doing what. So if I run this
Chinmay,
part, yeah.
I want to understand include dot lowest equal to true.
Yes. So
That is not clear to me.
that's what we are going to explore one by one. So here in the second line of the code, I didn't do anything. I just ran it. So my graph is coming as orange. Okay. Now I will tell you that what is happening. Then here I am adding another option. That's how you can learn that which label is doing what part. And I'm saying label is equal to true. So I added the label. And then see that what the difference is coming in my graph. So are you getting here? Label is added on the top. Got it? The moment I added labels is equal to true, you are getting these values are appearing on the top. Now, then I'm saying include lowest is equal to true, then let me run it. You will see the difference. Wait. Just a moment. So in this, just a moment, it is not making impact. Let me. So look here, what it is doing. It's though it's not visible here, but it's a logical expression saying that logical if true and xi equal to the breaks value will be included in the first. Now, so how it is happening, I will tell you. It is the mathematical notation. Let me explain you. So let's say that you are making some histogram and your histogram is making bins like 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Let's say it is coming like this. Now the question is 20 should come here in this bin or 20 should come in this bin. Where should it come?
First bin.
Where should it come? That's what the information we are passing. We are saying that include lowest is equal to true. That means in this case, this 20 is going to be part of this one. 20 will be not part of the other one. So this is correct. If I'm saying that include lowest equal to true, this will be correct. 20 will be not there. Got the meaning?
Yes.
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 That's what it is. So now read it. Equal to the breaks value will be included in the first or the last. So it's saying that it is going to include into the first bin or it's going to include into the second bin. Got it? So this it's your call. You have to decide that you want to include into lowest or do not want to include into lowest. Even you leave it, that will not make a big impact. That's what I was validating, that why difference is not looking, because it's not too big. But it is good to know. Perfect. Now, then wait, let me clean all the graphs. I run it here. And after that, I am saying x is equal to true. So you can run one by one and you can get it. Leave it. So I would say that x is equal to true is not, it is by default that is true. So I will tell you x is equal to true, AXES. So here it's saying that if you're saying that x is equal to x is logical, if true default, so default is true. So either you say true or it's not say, just remove it because that default is true. Now let's do one thing. At the place of true, we are saying false, and let's see that what is happening. That may give you a differential plot. So if I run it, did you see your axis has gone? X-axis, Y-axis. Did you get the difference?
Yes.
So these are the options. I would say that in the histogram or the box plot or even any of the graphical, the more and more you explore, you will come to know that how your graphs are looking. And we all know that role of this x limit and y limit. I hope this is clear.
Yes.
Yes.
Fine. After that, once that is done, so I'm running in a holistic so that my graph look good. Once that is done, then I am doing something here. I am calculating mean of the distance from the street. That is fine. I am calculating median distance from the street. That is also fine. I wanted to see the summary. That is fine. Just for the understanding purpose, nothing else. I need to run histogram distance from the street, how it's looking. Wow, it is looking very, very poor. Now, then what I am doing here, I'm going to calculate the standard deviation. That is, what is the standard deviation distance from the street? I wanted to showcase one thing. Standard deviation is coming as 20. That is perfect. I wanted to check that what is the impact of house price depending on the distance from the street. So I am running the correlation. And distance from the street has nothing to do with the house price. That means your house price is nothing, not correlated with the sales price is not correlated with the distance from the street. That is one thing. Now, I think it's not the way we did in the past for other variables, the same way we did, wherein I'm saying that u is equal to complete OBS. That's what I'm exploring. That is perfect. Now, there is if I'm going to run correlation on the entire house data, here you need to be careful that if I'm running the correlation on entire house data, it will be throwing error. Reason being, some of the variables in house data are numeric, some are not non-numeric. So I can't do in that way. So in that case, what is the requirement? There is a function called is.numeric. So I'm saying is.numeric on the sales data, and this will give me Boolean true and false. So sales price is saying that it's a numeric. That's what I wanted to check. Fine. Now,
other variables also, right, sir?
Yeah, I can check, but that's what I'm doing in line number 145. So I'm saying is.numeric on the house data. So on the entire house data, I'm going to use it. Fine. And I'm looking for numeric. So what it does, if I run it, look here. It is only giving me, look here, it is only giving me those variables which are numeric. Getting it? So what I'm doing here, I'm running this code and creating a data frame. Be careful, this filter option, filter is.numeric is my function and passing on the house data. It is going to create a new data set which names numeric df. I'm just naming it. And this is having only the numeric variables. Got it? Like, if you run the summary of numeric df, you will be getting that these are all numbers. Look here. Are you getting these are all numbers here, numeric, like ID, house type, distance from the street, carpet area, house condition, these are all numeric. So that's what I filtered out. Once that is done, then I'm going to run the correlation. In one go, I will run correlation of all the variables. That's what I'm doing here. I'm saying correlation on the numeric data frame, which I just created, and saying that u is equal to complete OBS. When I run it, this one, it will give me correlation with all numeric variables. That's what one requirement was. Someone told that how can I run correlation in one go and see that which one is highly correlated with house price. I did it. this is what it's doing. It's saying correlation, numeric df, you are passing data frame. In that data frame, you have house price as well. And we are creating a new object called correlation. So name of this object is correlation. Okay, it is done. Now the challenge is, if you open the correlation, it's a matrix here, it is stored. You can easily figure out. So your variables are written in rows and the same variables are written in column. You can figure out, let's say that you are looking for sales price. So look here, house type is highly correlated with sales type, with sales price. The carpet area is highly correlated. Look the values. Fine. Then let's see another variable. Number of bathroom is again decent correlated. Fine. Then this is how it is looking like. So we figure out that there are certain variables which are highly correlated to sales price by help of this complete correlation matrix. Is it clear?
Yes.
Yes.
I just wanted to convey that we are going to do everything, but it's only the matter of time that when are we going to do. Fine. Sometimes it so happens that you get such data and people say that, can you share the correlation matrix? So you're saying that yes, I can. So you're saying that's write.csv and this is your object correlation and you want to write that in by name of abc.csv. The moment you run it, and I need to go to my working directory. So let me go to my working directory. When I hit it, it is going to create an object called ABC, this one. And if I go here, there is ABC. If I open it, what all I saw there, that is what written here in the CSV format. Okay. What can you do? Let's say that you want to communicate to the stakeholder, someone has given you. You can share this correlation matrix that look how the correlation with every variable is looking like. Primarily, they would be interested to let me do something. I think sales price is at the end. So just hide it because this part will just share it. So look here. With sales price, you can figure out here. If you want to sort that, say from largest to smallest. Of course, sales price with sales price.
Huh?
Fine. This is how you find that how the correlations are looking like.
Can you please repeat? There's noise bit in background.
So guys, please mute yourself. I'm getting some noises coming. Now, this is how your correlation look like. Fine. So you can easily figure out that these top 3-4 variables, essentially the top 3, are highly correlated with the sales price. Got it?
Accordingly, we can use any variables, right? Drag down.
You can use any, but we are interested with the sales price to just check that which all are correlated with sales price.
All right, yeah.
Now, so I covered till here. Okay, I write the correlations and all. The remaining, there are many more things that I'm planning to do. So we'll do a lot of stuff to figure out that how things are. Remaining we'll cover in the next class.
We just go down, sir, to see that correlation, comma ABCCSV.
Correlation. Click on this one.
Yeah, just checking that formula, write.csv to export it.
This is write.csv, your object name, and how you want to write outside. This is outside name and this is your object name, which is inside.
Thanks, sir. Got it.
I will share this code. I think with recording, I will share this code. Fine?
Data also, sir. The same.
I will share. Yes, I will share it.
Data files.
Yes. So with that, I'm closing here. We'll connect on next Saturday. Fine?
Sure, sir.
Thank you. Thank you very much.
Thank you. Thank you, sir. Have a good day.
Thank you. Bye.
Thank you, sir. Thank you.